Alrighty, so here we are. It is time for doing some stuff here. Rory, what's going on? How is everyone doing today? We're gonna do visualizing data in Python, right? With Seaborn. Yeah. Visualizing data in Python with Seaborn. So we got a bunch of stuff there. Gonna do understanding Seaborn's classic functional interface, Seaborn's contemporary objects interface, deciding which interface to use, and creating different Seaborn plots using functions, creating data plots using objects. Okay. Excuse me. I'm just getting the voice all warmed up. Alrighty. Before I dive into that, I'm going to let's take a look at the schedule here. I have to move this. So we're going to do 2 or 3 sections of chapter 2 of the book Practical Statistics for Data Scientists, which I started last night or yesterday's stream. Data and sampling distributions. Going to look over random sampling, sample bias, make sure you understand our terms, and start doing some plots with this and start understanding some of the biases and sample mean and this stuff. This is just going to be a review, really, so I'm not going to spend a whole ton of time on that. So we'll start with that, and we'll do that all the way up till the bootstrap. So we'll do the 3 sections, so up till the sampling distribution of a statistic. And excuse me, so let's get started with getting a new job day. Oops, that's not what I want. Alt-N, that's going to get the templates and job hunt day. Get that going. It's going to be day 13, and this is visualize data with Seaborn. Sampling distributions. Kind of like, I may have lost the thread of what I'm using my format for the titles of these things. It's supposed to be an intention. Oh, I didn't capture my thoughts yesterday. I was just so tired. I didn't set an intention either. Yeah, so usually like the intention should be a verb. So let's do what was yesterday's intention? It was to refresh skills. Oh, actually, no, it was to explore something new. Explore new to me Python framework or library called Polars. Right, and that's what we did. And yeah, wow, what a day. I don't remember how many glasses of water I drank. I really didn't get enough. I'm gonna say 4, but throughout the day. 4 hours of Python tracked there. Let's go ahead and get the new day. Open today's date, and then as always, I need to replace the keyword with to-dos here. The monthly review we're going to do at the end of the week here. And my intention for today then is to refresh skills, data visualization, and statistic skills, basically. Did stretch, had a shower, stretched out the back. Should be good. I don't know, like, get Todoist opened. And I don't know, I've got to get to these frogs at some point, but I've just been pushing them off, which is why they're frogs. Things I don't want to do, but I mean, I've been kind of, most of the days have been taken up by doing these tutorials. It's like, it takes a long time for me to go dive deep into them. Really, like, let my brain process everything, basically. So let's go to here. And excuse me one second. Save the feature there, and then I need to get the chat all set there. Let you know what I'm up to here. Just trying to get ready here for looking for jobs. I'm going to be shifting away from this refreshing, and I'm going to start going into projects and connecting projects with roles that I'm looking to work at as, right, basically. So yeah, so next month for February, we'll be doing some projects, working on projects, refreshing the resume so that I can add those projects onto the resume, and start really diving into open roles. And yeah, so little by little, we'll get there. But I'm just having fun with this month, getting my confidence back, getting my understanding of data, like getting those neural pathways firing up again, connecting, and all that stuff, all that good jazz. Yeah. So I'm gonna hide that portfolio thing. We're not gonna work on that until like the weekend, probably. Even if so, this weekend is kind of messy, but okay. So that's what we worked on yesterday. We did look at data OpenGov. I should have a. Let me look for data sources. Okay, I do have a. Okay, there is data.gov. I do have it on there. I think what I want. No, it's not there. I think what I want. I'm gonna move this to my note. And just take a look at which things we have. 5 sources of data that are somewhat related. That was for doing a data engineering project, not really necessary to gather different data and coalesce it for this. That was kind of my goal of trying to do a data engineering project, which I never really started even. Search archive reader articles. That's not even a thing anymore. So I think what I want to do, I don't know, maybe I want to make a table out of this. I want to keep this in my back pocket so I know where this is. Actually, I'm gonna just move this to the front of the job hunt so that like I have that note kind of in my face when I need it. So we do have data.gov listed on there, data OpenGov. See how long that lasts. Dismal state of affairs here. It's only gonna get worse. Gonna get a lot worse. Let's see. But I gotta power through. Get through, try to find some work to survive here. Let's see. Okay, so I'm gonna start with the practical statistics, and we're gonna take notes on that. We started, what did I start with yesterday? I should have listed that note on here. What was the note that I used yesterday? I should come up with the most recent ones that I did. Oh, random sampling, and that one is in the inbox still. So let's move that to our job notes. So I'm just putting everything into this bucket. I'm using trying to adhere to Iago Forte's idea of para, separating your your kind of resources and stuff as into like what you're currently working on that has, so projects would be what you're currently working on that has an end date. And I'm not really good at adhering to that because there's a lot of things in here that don't really have an end date. So I've been trying to adhere to that a lot more. Practical statistics for data scientists, that's a thing. LinkedIn leaderboard, I could actually move this because I know that I don't need this right now. I can move this to the archive for 2025. And 2025 as projects. And I can create it, and I can just move that there. Because that's the thing that I kind of like loaded, but didn't really do. Interview questions is a lot. That's going to be part of that. So this is a thing. This interview questions. Oh, I'm going to actually move this to underneath the areas of focus. Sorry, I'm jumping all over the place. I want to try to give an overview and try to flesh out my own ideas from my head to my mouth. So areas of focus in the job hunt. So I want to put that into there. In Django blog, the back end. So that, yeah, so Django blog is a different project that I was working on. Could probably just dump that one too. So these are things I'm going through. I'm reading Medicare for All, which is the what do they call it? Like it's a guide for Americans or something like that. It's like a overview of the healthcare industry and the like how we got to this point of basically being beholden to large insurance companies and hospitals and what we need to do to fix that and this fractured healthcare system where people get healthcare from numerous different places. So depending on your circumstances, you get it from your employer, or you get it from the government, you get it from the healthcare exchanges on Obamacare, healthcare.gov. The idea with Medicare for All is to give a single payer solution to this, where government takes control of the healthcare, of like paying for the healthcare, and then yeah, and then the system kind of goes from there. Where yeah, it's all pretty good stuff. I gotta really come back to that. And then starting the Iliad, Friday night, there's going to be a meetup where they're doing like a reading of it. And that's in my area, so I don't think it's open to people outside of the area. So like my physical location. So yeah, so those are projects I'm working on. It's good. I'm just gonna go over like what my state of this is. This is kind of like part of my what I should do for my monthly review, but since I'm doing it now, it's pretty good. Then I started this 2025 analysis project. So this has an end date, right? This has an end date of at least 2025 at the latest. And I think that it's going to be sooner because I really want to end it by the at least the second at the latest second quarter, like my soft deadline. And 2025 is obviously the hard deadline, but we'll be working through it throughout the first half of this year. Django block that could be actually moved. I could move this. The problem with moving that is that there's files and stuff. I don't even know if I want it, so I might as well just like delete it, honestly. I can start that all up again. Like it was just really an exercise that I was doing. So I think what I'm going to do is I'm just going to delete it. It was really just boilerplate stuff. So I don't really need it. It's really just taking up space. I would archive it, but I just don't like see a need for it at all. Then I'm reading Practical Statistics for Data Scientists on this stream. And let's see, we have current professional projects and current personal projects as just queries, basically for DataView. And just gives a list of what the open projects are. Surprised that it doesn't come back with analysis projects. Is that... Oh, I think I know why. Okay, so I think what I need to do is actually add a new note from in here and call this README. Or README, or it could be the title of this 2025. Or I'll just say README. Just make this a readme.md. And tags. Could do tags. I don't know what kind of tags I want on this. I'm going to do this. So this is... a collection of projects and tutorials worked on during my job search of 2025. And then what I can do is go back, I think. Oh, that's weird. Yeah, that's fine. Okay. Okay. And I put a whole bunch of these things up there. I didn't get to talk about that. Oh, this is the daily note. Oh, but it doesn't update. So wait a minute. That was from Sunday. So wait, I could just go to that. Yeah, I can go forward. It's that one. Then go forward to that one. And then there we are. Okay, so that's good. I can navigate from there. I think I want to put that up in there. Yeah. I like having my like daily note available to me there. I've got a job search dashboard that I have like just a collection of resources. Not really a dashboard. But okay, so we have the monthly review and we need to work on that. I don't know why that's up on here. And then the Q1 plan. So this makes sense to have it up in this little area here. And I'm going to go, so document the process clearly. I'm trying to. At the very least, I can go back and like watch some of the stuff that I've done and try to recap. Probably should do that like after the quarter, as the quarter ends. Yeah, set up repository for all projects. So set cadence of build, 3 build days, 1 learn day, 1 apply network day. Okay. Yeah, okay. Did I push the portfolio there? I pushed the Django portfolio there to GitHub. Okay, so I'm going off script here, which, of course, I'm always off script. but yeah. So first phase is to wait a minute. Apply to jobs, prepare for interviews. Those are all part of the same thing. Engage with the first 3 chapters of practical statistics. I am working on that. Pick away at these things and complete RealPython courses, tutorials. Working on those, so that's going good. Data visualization, data science, Python web scraping for data sourcing. Okay, so right, so this is good for me to note for myself to set a cadence of 3 build days, 1 learn day, 1 apply to network day. So when I schedule that out at the end of this month, at the end of this week, actually, I'm going to keep that in mind. And we're going to find data sets. We're going to find fellow analysts to collaborate with, possibly. So if you're looking for a project to, work on and collaborate with me on, so please let me know. All right, my camera has some schmutz on it here. Gotta make sure that's making me look good here. I'm gonna take it. Okie dokie, I need some more water. Alrighty then. Ooh, yeah, my back is getting tight again. Small projects. Yeah, I wanted to pick some small projects and try to do like 1 a week while I'm working on like this bigger project, and just do like one learn day as that, like, yeah, apply a network day. Yeah, okay. And then in March, we're gonna complete the Landing a Data Job course by Alex Friedberg. Then we'll like really tailor the job resume to that. Yeah, to resume to each job description. Creating a resume with a human viewer in mind, and we want to quantify every bullet point in my experiences. This could be pretty hard. Identify and reach out to recruiters, working with the companies I want to work for, and create a phone interview cheat sheet. Those are all things that are on the horizon. Currently, I do need to find some way to like integrate the like SQL learning. I think maybe while I'm building, one of the learn days should probably be like going through like SQL cookbook or something like that. Just to really understand. Get back to doing queries. Query problems. Yeah. Okay, so back to my vault structure. Trying to do para, right? Which is projects, areas of focus, resources, and archive. Basically, the projects is the hot thing, right? That's like thinking of like the way that some cloud service providers, cloud providers think about storage. You have hot storage, which can be accessed immediately. You have like kind of like cool storage, which can be accessed after kind of like a little bit of time. And then there's cold storage, which needs to be like, sometimes they say like rehydrated and put into cold storage. So I chose like colors for that to kind of indicate that, where projects are the hot button thing. Like those are the things that we're actively working on. So I'm going to do that now. And then areas of focus are the things that are kind of like projects that are like warm. These are the things that are currently working on, and it's an area that we are just focused on, right? So I have yeah, the job hunt obviously is the main thing. That's the main area of focus right there. I have content creation that could actually be moved because that's not really an active area of focus aside from doing these live streams. I have exercise, which I have just an exercise ledger in there, which I need to start adhering to. I need to start adding stuff into there. Basically, I just had a, yeah, I have a way of adding timestamps with the exercises that I would do. And I'm gonna like, obviously I haven't done much. This was just like to test it and make sure that I knew how it was working. um, yeah, I need to start doing the like I do like kind of like to do the like calisthenic stuff that you don't need weights or anything other than that. And it's just been difficult. My like joints have been pretty achy, tight. So we have our financial is always a area of focus, and I have my health, I have my dog, Hypatia, her needs. She's always on my mind, and her health and well-being, and portfolio is another thing. And my wife will probably kick me for not having a Molly folder for her. But okay, so we have portfolio. Okay, so this all makes sense to me. You can see my current areas of focus on here, and then oh yes, this is a nice query where I put like when it was last updated, so I can see like if it's something that's kind of yeah. This doesn't list the overall folder, which is a problem, I guess. Let's see. Let's go back. Go back to the current projects again. Just make sure that that's on there. I think that was yes. In our 2025 analysis projects are in there because I put the README file in there. And I got resources, and these are like just coding projects, content creation, Excalidraw, and then just like files. Audio books, config, data, documents, images, scripts. So like the Python scripts and stuff that I run there. Bash. Do they have like a? Let me get an icon. I need to get an icon from Iconize, even though Iconize sucks. I need to find that. There was something that's supposed to replace this, and I gotta find that. We want to find the shell, just like the okay, just not PowerShell, but just shell, right? Is there bash? New bash. Base heart bash. Okay. B ash. BXH ash. Such a weird weird search. Okay, so I guess what I'll do is just like command prompt or something, maybe terminal. Yeah, a terminal will work for that as well. Although I would like to have, yeah, I guess that's fine. Yeah, I'd like to have the filled one though. Terminal box filled, just like that, maybe. Yeah, that's fine. I have my logs, which doesn't need to have that on there. But yeah, so then I have slides or slideshows and stuff. It's interesting. Okay, so I think, yeah, I was going to start building them out of here. Although, I guess as PDFs, I don't know. If I'm working on something with a project that I'm like going to save with LibreOffice, I think we'll do that. Videos Contemplator V2. What the heck is that? What the heck is this? Oh, right. Oh, this was I think this was for FedEx or something. This is the bullshit like personality test that they made you take. Ah, I'm a contemplator. Right, so that's a room for growth. Is you find socially stimulating environments draining. So if you have autism, then why don't you work on that? Improve your autism. Such bullshit. Tempted by new approaches. Yeah, just, don't be curious. Stop being curious. Why? You need to not. No. Okay. They always couch these things like room for growth as it's like it's pretty much ingrained in your body chemistry and your brain chemistry and all that stuff. And they're like, you have to work on that. Why don't you work on it and make it? Why don't you be less autistic? Your tabs, stage. Okay, and the queries. Yeah, so I had queries. Okay, and templates and thoughts. Templates are important. That's where we get all of our structured notes that have the follow a certain predetermined structure. And like templates aren't static either. I kind of like go in and I edit them and I augment them or I alter them. Either add things or take them away. And let's see. So I want that on there. So current resources. And I don't know why learning sessions are on here. I don't know where that's supposed to go. This was my collection of that. Maybe I'll put that in videos because that's where it's like linking to videos. So maybe I'll just put that in there. Or I don't know where to actually put that. You know what? I don't know where it should go. In fact, Python, these things, part of Azure programming thing. What was this one? Oh, I was just like recording myself doing that stuff. Okay, well, that's fine. Okay. Yeah, I'm just gonna move it to archive. Oh, we'll just put it in the archive. This is, yeah, I don't know where it's supposed to go. Just dump it there. And the archive is the cold storage, so I just have it divvied up by year. Basically, at the end of the year, I just dump everything into their respective like folders. And then I have in unfinished tasks. Always create that file from since 2023 is when I started to do that. Yeah, I have stuff dating back to 2021 when I wasn't using Obsidian. I was using VS Code. 2023 there, and then that. Okay, so that's basically, yeah, that's basically the layout there. Or shall collapse that. Get started with this here. Close that data sources. Yeah, so I think we're good to go. So, and I'm like now tired and I need to take a break. But let me try to recenter. And we'll come back, we'll do random sampling and sample bias. And then we'll do sampling distribution of a statistic, and then we'll do bootstrap. Oh no, not bootstrap. We'll do selection bias and sampling distribution. Yeah, these three. That'll be it. Let's see, is there like an update or something? Restart extensions. Okay, there's just something there. Okay, be back in I'm gonna say 20 minutes, but I think what I wanted, yeah, give me 20 minutes. But I'm also gonna work on something while I do that too. 20 minutes from the time that I finished doing the thing that I was gonna to get the timer up, basically. So yeah, so okay. We're taking a break now. Let's see. So we're back. Picking back up where I left off yesterday. Random sampling and sample bias. I'm going to leave a stream marker. This is where we're starting. Random sampling and sample bias. Yeah. So I took a note on sampling and stuff and played around with a bunch of little internal links with Obsidian here. And the music you hear in the background, let me make a note of that, is used with permission from my friend Josh. It also goes by the handle the Aftermath Equation, and you can check out his YouTube in the link in the description, and check out the title playlist that I have as well. So let's go ahead and see what I can do here with this. So I have a whole bunch of definitions. We're going to define our terms, have something that we can point back to. Bias, I would like to flesh out bias and sample bias as get those definitions a little bit more, fleshed out. I guess like don't really need to do much with a sample. Sample is a subset from a larger data set, obviously, and a population is a large defined complete set of data. That's what I would say. The complete, I added the word complete to that. I just think that it's makes more sense that it's like represents the whole of something. So random sampling is a process. All right, so we already did that yesterday. I'm going to read this again. So the classic example is the Literary Digest poll 1936 that predicted a victory of Alf Landon over Franklin Roosevelt. The Literary Digest, a leading periodical of the day, polled its entire subscriber base, plus additional lists of individuals, a total of over 10 million people, and predicted a landslide victory for Landon. George Gallup, the founder of the Gallup poll, conducted bi-weekly polls of just 2,000 people and accurately predicted a Roosevelt victory. The difference lay in the selection of those polled. Excuse me. The Literary Digest opted for quantity, paying little attention to the method of selection. They ended up polling those with relatively high socioeconomic status, their own subscribers, plus those who, by virtue of owning luxuries like telephones and automobiles, appeared in marketers' lists. The result was a sample bias. That is, the sample was different in some meaningful and non-random way from the larger population it was meant to represent. Right. Yeah, misrepresent sample bias is a sample. What? That misrepresents the population? That's what? I don't agree with that. We know a sample is a subset from a larger data set that okay, yes, okay, that does make sense. Yeah, a sample that misrepresents the population. So let's go with let's add some links to this just because I like doing this now. It's a sample. We want to link to a sample, and it misrepresents the population, so I know what that one is. Let me see if it works if I just do it like this. Yeah, that works. Okay. Sample is a subset from a larger data set that misrepresents a popular. What? Ooh. Got some bright synths going on here. Right. Okay, I like the way this looks better. Self-selection, sampling bias. Okay, so the reviews of restaurants, hotels, cafes, and so on that you read on social media sites like Yelp are prone to bias because the people submitting them are not randomly selected. Rather, they themselves have taken the initiative to write. This leads to self-selection bias. Let me get a. Yeah. Okay. So yes. Okay. I think I want to like flesh this out a little bit more. Sample biases. Cognitive or like cognitive things. Cognitive bias, not cognitive. Sample, like I don't know. Let's flesh this out as a and self-selection. Hang on one second. High pitch is. Okay. The fish is whining at Opal. There's the dog versus cat thing going on here. So self-selection bias. The people motivated to write reviews may have had poor experiences, may have an association with the establishment, or may simply be a different type of person from those who do not write reviews. Note that while self-selection samples can be unreliable indicators of the true state of affairs, they may be more reliable in simply comparing one establishment to a similar one. The same self-selection bias might apply to each. Yeah. So I will say self-selection bias occurs when let me see something now. Let me get that out first. I don't know why. I just like okay. Self-selection. There we go. Self-selection sampling bias, and I can refer to that. This is awesome. Okay. Now I'm getting the hang of linking between notes here. Occurs, this is like just like 2 years into using Obsidian, and I'm just finding this out. Right. So when does this occur? Let me put this into my own words. Self-selection bias or self-selection sampling bias occurs when the let's say when the data provided when it comes from a group of I want to try to be as like What was the thing that my math professor was saying? You want it to define like everything. You don't want to be too precise that it's like doesn't cover the whole thing. Let's see. Provided comes from a group of I would say like participants, or I think it's specifically because they choose to be a part of a survey from a group that chooses to participate. In a survey. It really comes from survey data, I think. In a really not, it could be survey or research. It could be just in general research, but in our context, it's going to really show up when it comes to surveys. That's mainly what I'm going to be concerned with. Statistical bias refers to measurement or sampling errors that are systematic and produced by the measurement of a sampling process. Okay, so I'm going to flesh this out. I'm going to take this entire thing here. I don't like that there's a gap in between those lines there. I don't know. I think that's the way I would phrase this. Statistical bias system. Okay, I'm missing a word. I accidentally a word. So statistical bias refers to systematic errors or measurements produced by the sampling or measurement process. So I can even like flesh this like random sampling. So measurement is also a thing. Bias. This is just the general idea of biasing. Of bias. Cool. I'm getting the hang of making notes in Obsidian. Look at that. Okay, so let's talk about statistical bias refers to that. Yep. An important distinction should be made between errors due to random chance and errors due to bias. Now consider the physical process of a gun shooting at a target. It will not hit the absolute center of the target every time or even much at all. An unbiased process will produce error, but it is random and does not tend strongly in any direction. Oopsie. Sampling bias is a sample, and misread is a sample image. Yeah. Yeah, I need to quantify. It's systematic or measurement errors. That makes much more sense. Yeah, a statistical bias refers to systematic sampling or measurement errors produced by the sampling or measurement process. I think we can just get rid of this and just say errors. Statistical bias refers to systematic errors produced by the sampling or measurement process. That sounds better. That sounds good. That sounds concise. It sounds complete. Sounds good. An important distinction should be made between errors due to random chance and errors due to bias, right? So that's the systematic part, right? The systematic errors are not random. They're not equitable, right? Consider the physical process that the results shown in 2.3 show a biased process, right? There looks like there is still random error in the both y direction, but there is also bias, right? We're not getting like up in the upper left or the lower right quadrants. Yeah, shots tend to fall in the upper right. Yeah. Upper right quadrant. Yeah, along an X there. Oh, and that second one. So, okay, so... Oh, this could be a random thing, though. Scatter plot of shots from a gun with true aim. It still looks biased to me. It still looks like there could be some bias, but like the... you'd have to look at... Yeah, you'd have to look at that. So this is like where it's off-center. So that's what they're saying, is that it's centered around 0. Okay. This is centered around something else that's off the origin here. That's with bias team. So bias comes in different forms and may be observable and invisible. When a result does suggest bias by reference to a benchmark or actual values, it is often an indicator that a statistical or machine learning model has been misspecified or an important variable is left out. Right. To avoid the problem of sample bias that led to Literary Digest to predict Landon over Roosevelt, George Gallup opted for more scientifically chosen methods to achieve a sample that was representative of the U.S. voting electorate. There are now a variety of methods to achieve representativeness, but at the heart of all of them lies random sampling. Do we have random sampling? We do. It's not always easy. Proper definition of an accessible population is key. Let's highlight that. That seems like a interesting thing to highlight there. Suppose we want to generate a representative profile of customers, and we need to conduct a pilot customer survey. The survey needs to be representative, but is labor intensive. First, we need to define who a customer is. We might select all customer records where purchase amount is greater than 0. Do we include all past customers? Do we include refunds, internal test purchases, resellers, both billing agent and customer? Next, we need to specify a sampling procedure. It might be to select 100 customers at random, whereas sampling from a flow is involved, real-time customer transactions or web visitors. Timing considerations may be important. A web visitor at 10 a.m. on a weekday may be different from a web visitor at 10 p.m. on a weekend. Right. I'm just remembering that Khan Academy has some pretty good examples of this to think critically about sampling bias, and I might want to revisit that. Maybe do that today. I'm not sure. After this. Okay, so in stratified sampling, the population is divided up into strata, and random samples are taken from each stratum. Political pollsters might seek to learn the electoral preferences of whites, blacks, and Hispanics. A simple random sample taken from the population would yield too few blacks and Hispanics, so those strata could be overweighted in stratified sampling to yield equivalent sample sizes. Right. Yeah, because, yeah, There could be different sizes to that. So there's a way to kind of counteract that with, in some senses, in some cases with like chi-square tests. If you're doing a count that way. Yeah. So the size versus quality, when does size matter? In the era of big data, it is sometimes surprising that smaller is better. Time and effort spent on random sampling not only reduces bias, but also allows greater attention to data exploration and data quality. For example, missing data and outliers may contain useful information. It may be prohibitively expensive to track down missing values or evaluate outliers in millions of records, but doing so in a sample of several thousand records may be feasible. Data plotting and manual inspection bog down if there is too much data. Right. I thought we saw an example of the data plotting, like, not looking great. When you have like so much data that there's just like ends up looking like noise, right? You need to be able to find the signal in there. And that's what you should be kind of graphing, right? It's what you should be plotting. So when are massive amounts of data needed? As the classic scenario for the value of big data is when the data is not only big, but sparse as well, okay? I don't understand what that means, though. Consider the search queries received by Google, where columns are terms, rows are individual search queries, and cell values are either 0 or 1, depending on whether a query contains a term. The goal is to determine the best predicted search destination for a given query. There are over 150,000 words in the English language, and Google processes over 1 trillion queries per year. This yields a huge matrix, the vast majority of whose entries are 0. Right, okay. They're like a sparse matrix. Naturally, this is a true big data problem only when such enormous quantities of data are accumulated. Can effective search results be returned for most queries? That's an awkward sentence. Only when enormous quantities of data are accumulated can effective search results be returned for most queries. And the more data accumulates, the better the results. For popular search terms, this is not such a problem. Effective data can be found fairly quickly for the handful of extremely popular topics trending at a particular time. The real value of modern search technology lies in the ability to return detailed and useful results for a huge variety of search queries, including those that recur with a frequency, say, of only 1 in a million. Consider the search phrase Ricky Ricardo and Little Red Riding Hood. In the early days of the internet, the query would probably have returned results on the band leader Ricky Ricardo, the television show I Love Lucy, in which that character appeared, and the children's story Little Red Riding Hood. Both of those individual items would have had many searches to refer to, but the combination would have had very few, right? The intersection of both of those two sets. So later, now that trillions of search queries have been accumulated, this search query returns the exact I Love Lucy episode in which Ricky narrates in dramatic fashion the Little Red Riding Hood story to his infant son in a comic mix of English and Spanish. So keep in mind that the number of actual pertinent records, actually tighten this up a little bit here. Okay. A number of actual pertinent records, ones in which the exact search query or something very similar appears, together with information on what link people ultimately clicked on, might need only be in the thousands to be effective. Some of this writing is a little awkward. However, many trillions of data points are needed to obtain these pertinent records. See also long-tail distributions. And sample mean versus population mean. I think we have. kind of do want to move that to my notes here. Okay. Maybe I don't need to make a distinction here with this, or make a note of this. I feel like it's just like kind of natural. The symbol X bar is used to represent the mean of a sample from a population, whereas mu is used to represent the mean of a population. Why make the distinction? Well, information about samples is observed, and information about large populations is often inferred from smaller samples. And statisticians like to keep those two things separate in the symbology. Nice. So the key ideas here, I'm going to highlight this because I like to do that. Highlight the key ideas and highlight that. Maybe I want to take a note of that, honestly. Or maybe I put it back into the related notes, like my notes or something, side in this book. Chapters, excerpts, and quotes. Maybe like key ideas. Copy that. Copy that. Okay. That's weird. So, yeah, so some of these, there's line breaks in here that I want to get rid of. There we go. So even in the era of big data, random sampling remains an important arrow in the data scientist's quiver. Bias occurs when measurements or observations are systematically in error because they are not representative of the full population. Data quality is often more important than data quantity, and random sampling can reduce bias and facilitate quality improvement that would otherwise be prohibitively expensive. And then there's some further reading here, Sage Handbook of Online Research Methods, sampling methods for online surveys. And the story of that failure can be found at the Capital Century. Let's see, where is that? There we go. It's up down here. Up, down, all around. The poll that took America's pulse. So I think I'm going to add this, and then I'll link it in the, whatchamacallit. Yeah, back to that. Oh gosh, and it does that again. No. Okay. Boom, 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 boom. Oh, it says the John Blackwell, and it was published, I don't know when. The Trentonian. Interesting. It says that it's the Trentonian, but it doesn't say that. Yeah. Just manually adjust this here. Don't know when this was published, but it's oh, we can even copy this image and put that in there as well. Just be sure that we have that. Or we could put the, oh, well, that's fine. Okay, so it's in JPEG, but Gallup and his full staff at their Princeton. What is the job? Readings? Readings. There we go. Maybe this will move that, but maybe not. It would be nice if it did that, wouldn't it? If it just moved it automatically to there, to that asset folder. Either way, it's fine. We'll just put it in the publisher. So this is an article, and its publisher is Trentonian. Must be in New Jersey, Trenton. So there's that. There's that story there. So I'll actually link to this in the chat here. Save that one there. Okay. Okay. So I'm going to take a quick break, come back, and we're going to look at selection bias. I don't know about this sampling methods for online surveys. Maybe I'll... Yeah, I don't know about whether or not I'll highlight this or not. Review of modifications and random sampling that are often used. It's like one of those things where I'll just like add it to my like reading list and never get to it. So that's pretty good though. So we'll come back, we'll go through selection bias. I don't know if there's any code in this section. No, but in sampling distribution there is. Okay, so that's when we'll get to that. Yeah, so we'll do a little bit of code from there. And really just a little bit of code. Okay. Yeah, okay. Well, it is just the beginning of this chapter, so be back in say like 10 minutes. Okay, so let's get going with what do we call it? Oh, I gotta yeah, should be actually a verb. Let me see. And read. There we go. Selection bias. Do I want to keep a note on this? Probably. probably want to make a note on this. Yeah. Selection bias. We'll do analytics. Oops. Is slash analytics. There it is. Yeah. I don't know why I keep going back to the hash just for the search. It's probably easier to do the tags from here. And this is going to be in stats. Oh, there's also data science statistics. I don't know why I have two different contexts there. So we're going to get some definitions going here. And first, to paraphrase Yogi Berra, if you don't know what you're looking for, look hard enough and you'll find it. Okay, selection bias refers to the practice of selectively choosing data, consciously or unconsciously, in a way that leads to a conclusion that is misleading or ephemeral. Ooh, the fleeting conclusions. Let's define selection bias. Okay. So it is, let's get the word bias, because I know that it's coming from random sampling. Yeah, okay. Okay, so selection. Selection bias is bias from the, let me fix this here, capital away, bias resulting from the way in which, well, they're defining as bias resulting from the way in which observations are selected. I hate using in which. Seems kind of circular, though. Obviously, it's selection, the way that they're selected. I kind of want to, like, say something like when... Well, the result, it's not really a definition. Okay, so usually definition is just like something is. From the way in which observations are selected. Selection bias is bias. I guess it's fine. Until I have a better way of wording this. Yeah. And then we can do... Data snooping. Ooh, what's that? Like Snoop Dogg. Excessive hunting through data in search of something interesting. Oh. Like cherry picking kind of, right? Or like... interesting. I would say data speaking refers to search of something interesting. And then we got a vast search effect. These are all new terms to me. Data snooping and vast search effect. I've heard of selection bias. So this is going to be... Let's do... Vast search effect. Oh, so let me just come back over to here. Bias or non-reproducibility resulting from repeated data modeling or modeling data with large numbers of predictor variables. So it's really like kind of akin to like the law of large numbers. Like, well, I guess maybe not. Repeated data modeling data through... yeah, I'm going to see what they mean by that. I might actually alter this definition in my notes. Yeah, let's come back to that. Do they talk about that? Fast search effect down here, okay. Okay. So if you specify a hypothesis and conduct a well-designed experiment to test it, you can have high confidence in the conclusion. This is frequently not what occurs, however. Often one looks at available data and tries to discern patterns, but are the patterns real? Or are they just the product of data snooping, that is extensive hunting through the data until something interesting emerges? Okay. There's a saying amongst statisticians: if you torture the data long enough, sooner or later it will confess. Okay. Fun. Okay. The difference between a phenomena that you verify when you test a hypothesis using an experiment and a phenomena that you discover by perusing available data can be illuminated with the following thought experiment. Okay. Okay, difference between testing a hypothesis and perusing data. Okay. Imagine that someone tells you they can flip a coin and have it land heads on the next 10 tosses. You challenge them, the equivalent of an experiment, and they proceed to toss the coin 10 times with all flips landing heads. Clearly, you ascribe some special talent to this person. The probability that 10 coin tosses will land heads just by chance is 1 in 1,000. Now imagine that the announcer at a sports stadium asks the 20,000 people in attendance each to toss a coin 10 times and to report to an usher if they get 10 heads in a row. The chance that somebody in the stadium will get 10 heads is extremely high, more than 99%. It's 1 minus the probability that nobody gets 10 heads. Clearly, selecting after the fact the person who gets 10 heads at the stadium does not indicate that they have any special talent. It's mostly likely luck. Right. Okay. So yeah, you have to take... that's like a logical fallacy. The sharpshooter fallacy, I think, is similar to that, where you imagine that somebody... What's the difference between putting a target up and having somebody shoot at the target and taking that result, right? And seeing that the person hit the bullseye, right? Versus somebody shooting at a blank wall and then putting a target around the holes that were shot, right? That's basically the sharpshooter fallacy. Clearly selecting after the fact the person who gets 10 heads at the stadium does not indicate that they have any special talent. It's mostly just luck, right? Since repeated review of large data sets is a key value proposition in data science, selection bias is something to worry about. A form of selection bias of particular concern to data scientists is what John Elder, founder of Elder Research, that's not research into elders, that's his name. A respected data mining consultancy. Calls the vast search effect. Okay. So that's attributed to... So this is, okay, that's good to note. So this is going to be attributed to what's a coinage of term attributed to John Elder. Actually, italics. There we go. The vast search effect. The vast search effect is a form of. We'll do selection bias, but we'll do it from selection bias. In which, where repeated I'd say like quote unquote like interesting results That's what I'll say. The vast search effect is a form of selection bias where interesting results emerge from a large data set after repeatedly running different models and asking different questions. Right. We can guard against this by using a holdout set. There's sometimes more than one holdout set against which to validate performance. Target shuffling. Permutation test, right. Permutation test. That's what I think. We'll talk about that. It's like shifting the columns or something. Like shifting values around in one. So imagine a column and just like permuting the values of the column and seeing if there's an effect there. How important, like you see how that affects the model, basically. If it changes the performance of the model, then that column is probably important, right? That's like a way of testing feature importance. Right. Typical forms of selection bias in statistics, in addition to the vast search effect, include non-random sampling, cherry-picking data, selection of time intervals that accentuate a particular statistical effect, and stopping an experiment when the results look interesting. Right. Okay. Yeah. Okay. What the heck did I write there? Definitionian? Watch out for your definitionians. Regression to the mean. That's when you, like, are trying to be really good. And you're being real kind to people. And you're real nice. But then, like, you know, just wears down. Then eventually you start regressing to the mean. Start snapping at people. Refers to the phenomena involving successive measurements on a given variable. Extreme observations tend to be followed by more central ones, right? I'm going to just take this verbatim, honestly. I'll highlight that, but that's going to be my definition of that. Comes from that observation that extreme observations tend to be followed by more central ones. So as their example, sports fans are familiar with the Rookie of the Year sophomore slump phenomenon. Among the athletes who begin their career in a given season, the rookie class, there's always one who performs better than all the rest. Generally, this quote-unquote Rookie of the Year doesn't do as well in his second year, and so why not? In nearly all major sports, at least those played with the ball or puck, there are two elements that play a role in overall performance: skill and luck. Regression to the mean is a consequence of a particular form of selection bias. When we select the rookie with the best performance, skill, and good luck... Wait. Gosh. When we select the rookie with the best performance, skill and good luck are probably contributing. I don't know why I just elided over that comma and just thought that that was one full sentence instead of two independent clauses. Or a dependent clause and an independent. Yeah. In his next season, the skill will still be there, but very often the luck will not be, so his performance will decline, it will regress. The phenomenon was first identified by Francis Galton in 1886. Sure, it's not... Oh, that's weird. Go back up. Oh, we got to sort by newest. Okay. Oh, it's JSTOR. Fuck JSTOR. They seriously, like, put this stuff, like, this would be, like... Oh my gosh. Looking at this article. Okay. An article from what? The 1800s? What? They keep renewing the rights? 1886. This should be in the public domain. And yet it's not. Because fuck JSTOR. Jesus. Friggin' Christ. Right, okay. The children of extremely tall men tend not to be as tall as their father. And probably the similar with like on a short. If you're extremely short man, probably gonna have children that are taller than them. I don't know what mid-parents are. What a weird way to phrase this. Yeah. The 19th century was something, huh? When mid-parents are taller than mediocrity, Gen Z is going to be like, well, mid-parents are mediocre, aren't they? Their children tend to be shorter than they. Break that one out at a party. When mid-parents are taller than mediocrity, their children tend to be shorter than they. What? Let's break this down to like current English. When parents are taller than average, their children tend to be shorter than them. Yeah. Regression to the mean, meaning to go back, is distinct from statistical modeling method of linear regression, obviously, in which a linear relationship is estimated between predictor variables and an income variable. So it's not really, it's like a regression meaning to go back, not as the process of regression there. Okay, so we'll highlight these key ideas. Go to the random sampling, and we'll go to the practical statisticals. No, where are we going? This one. And we'll add some more key ideas. Got any more key ideas? I have some very good ideas about keys. Oh, you son of a... What is going on here? Maintenance. Okay. Specifying a hypothesis and then collecting data following randomization and random sampling principles ensures against bias. All other forms of data analysis run the risk of bias resulting from the data collection and analysis process. Repeated running of models and data mining, data snooping and research, and after the fact selection of interesting events. Okay. maintenance guy is yelling at the door next door. Surprisingly not a statistics journal, this thing. Okay. I'm surprised. Really am. Of course, fooled by randomness through selection bias. Michael Harris. Stock market trading schemes. Yeah. Fooled by randomness was also a title of a Nicholas Taleb book, wasn't it? Okay. And then we just got to go through sampling distribution of a statistic, and we are done with the reading portion of this, or at least the the book portion, right? Now let's move this over to our notes. And selection bias, sample biases, these things here. Oh, I gotta it's my resources here. So the notes I took here are random sampling, sample biases. It should just be like the most recent ones, shouldn't it? Yeah, here we go. And selection bias. So with selection bias, we gotta move this to our job notes as well. Okay. Sample biases, selection bias, and then we're gonna have another one. It's gonna be called sampling. Of a statistic, and I'll just go ahead and click through there, and I'm just gonna go ahead and copy the tags and paste them there rather than type all that other stuff up. Do we have a sample statistic note? I wonder if I should. It is kind of acting a bit sluggish. Obsidian is. Trying to think if I should enable Omni Search. I don't know if that's good though. This is weird. Where I put search, I don't know where I want this actually. Do I want it like up here? Maybe? Maybe I want it up there. I'm honestly not sure. Problem is that looks for statistics. It looks for statistic, and it looks so it doesn't. I don't know. Can I put them in quotes or something? How do I search? I gotta learn how search works in Obsidian because I'm not that good at it. I'm sure the docs are pretty good though. Oh, here we go. Wait a minute. Someone's got a pretty good article here by the looks of it. You know, it's always good when they have a quantifier. 5 hidden features. Oh yeah, it's mysterious. Which are the 5 ones that I don't know about? Search core plugins is going to be search. Turn it on. I'm sure I have it on here. Do I not? We have search. What is hotkey though? Control Shift F. It's global search. of course, Natch. So we need to know about like search operators. Let's see. Standard word search. Standard word search are there. Okay, so or yeah, you can obviously use. I don't like the choice of font here. It's kind of difficult to distinguish between the code blocks here, the callouts and stuff. Okay. Oh, look at that. I have a note on statistical inference where it says sample statistic. So if I do sample statistic, it will have, yeah, it's going to have those things in the same note though, but we wanted it on the same line, right? Interesting. Okay, so this is kind of like the mode that I'm trying to get into, is to synthesize these things, to take my existing knowledge, the notes that I have on this, search, find which ones I have, and either flesh those notes out more or link them together. Just like studying technique, I guess. Just trying to get those. Get my first brain working well. It treats that phrase essentially like a single word. Obsidian rocks. If you add quotes to it, it treats it like a single word. Right. Okay. That makes sense. That's what I used. Yeah. Exclusionary search. You just put minus rocks. It's a great operator. Okay, so power user features. They're extremely handy if you remember to use them, but they can be hard to remember. Search operators allow you to do things like this. So you can search for tags. You can search for test that. You can search for the other stuff too. Okay. I really want to get better at searching because to really navigate this vault of notes and stuff, I think it's better to understand how to search, because I might have things that are not structured. In fact, I have a lot of things that aren't structured and a lot of notes that don't have a tag. And, well, they all have tags, I think, but like some of them don't have I don't know, like interlinks, links related to other notes. Oh, you can embed with query. This is a really good article. I kind of like it. I need to use the restroom and then I'll be right back and we'll talk about sampling distribution of a statistic and we'll finish up because there's just a couple of pages there. So then we'll get to the other stuff in about an hour. Probably top of the hour, we'll be working on visualizations with Seaborn. So yeah, so be back in 10 minutes. There we are. All right, we're going to go over some sampling distribution of a statistic. So got to take some notes here. And let's go with start with sampling distribution here off that list there. So the term sampling distribution of a statistic refers to the distribution of some sample statistic over many samples drawn from the same population. Much of classical statistics is concerned with making inferences from small samples to large populations, very large populations. Okay. I actually like the one that they have in the list. A sampling distribution of a, and then we have sample statistics. So let's do. We'll define that in a second. Many samples or resamples. They didn't define resample. I don't know what that's gonna, it's just repeated samples. And go with sample statistic and a sample statistic is a metric calculated for a sample of data drawn from a larger population. That's kind of redundant, I feel. Calculated from a sample. The way that we've defined a sample of data is that it's coming from a population. Or, yeah, I guess. I guess to be more precise there. I'm still just going to say sample. Drawn from a larger population. I mean, that's just the way that we define it. I'm just going to say from here, because I'll reference which one I'm talking about. Random sampling. Oh, come on, really? Okay, whatever. Oh gosh, come on. Oh, you have to do the hash first. Okay, right. Sample. There we go. And a distribution, data distribution. So a data distributino is apparently the way my fingers want to spell that. Is a frequency distribution. I forget what the definition was from our probability course. Values in the data set. And we have I think I have something to refer to this, just as fun, just for fun. Hang on a second. Values? Yeah, my values don't work. Where did I put that note? What was that note? Observation? I have an alias somewhere for... Oh, well. Nah, I'm just not gonna link it. The central limit theorem. What? I actually like the way that they define that there. The term refers to the distribution. Yeah, I missed a whole bunch of words here. um, okay, refers to the distribution. Okay, I'm just gonna leave it. Okay. Sampling distribution of a sample. Frequency distribution. Oops. Of a sample statistic over many. That's what I was missing. Okay. Central limit theorem. Let's go central or the what was it? CLT for short is the tendency of the sampling distribution. Let's link the sampling distribution. You take on a normal shape, and we're going to define that later. Not a normal, normal. As sample size increases, we'll say, instead of rises. As the sample size gets large, I would say that. Instead of increases, because that's just, yeah, gets large. So the sample sum gets large or becomes large, gets large and larger. I don't know. I don't know. I like that wording. The standard error, okay. Okay, so the variability standard deviation of a sample statistic over many samples, not to be confused with standard deviation, which by itself refers to variability of individual data values. Yeah, actually we probably should put that note in there. Variability, so the standard error refers to the variability of a sample statistic. And again, we'll look for that sample statistic. Click back to over many samples. I think I have a note on variability. I can't remember. Estimates of variability. I think we'll link to that. Yeah, there we go. Sample statistics, sample of the data. There we go. Everything's linking up nice. Okay, so we also want to put a note here, right? So we want to say, let's do a note. Yeah. Okay, I'll say not to be confused. And then we had estimates of variability. And we want, right. Okay, so we're gonna do the hash and we're gonna do the caret there. Standard deviation. Itself refers to variability of individual data values. Okay. Okay, typically a sample is drawn with the goal of measuring something with a sample statistic or modeling something with a statistical or machine learning model. Since our estimate or model is based on a sample that might be in error, it might be different if we were to draw a different sample. We are therefore interested in how different it might be. A key concern is sampling variability, right? Okay. If we had lots of data, we could draw additional samples and observe the distribution of a sample statistic directly. I just want to highlight this whole thing. Come back to that at some other point as well. Okay. Typically, we'll calculate our estimate or model using as much data as is easily available. So the option of drawing additional samples from the population is not readily available. So sampling the samples, okay. It's important to distinguish between the distribution of the individual data points known as the data distribution and the distribution of a sample statistic known as the sampling distribution. Right, so let's try to understand that. So sampling distribution is the frequency distribution of a sample statistic over many, right? Okay, so I got to flesh that out again, right? That was okay. Um, right. Yeah. So as far as like sample statistic could be a mean, could be the mean that you're trying to understand, right? And you're doing multiple calculations of the mean. So that's the sampling distribution, right? Right, and as their example, exactly, the distribution of a sample statistic such as the mean is likely to be more regular and bell-shaped than the distribution of the data itself. That is definitely something to highlight and note. The larger the sample the statistic is based on, the more this is true. Also, the larger the limit, the narrower the distribution of the sampled statistic. So this is illustrated in an example using annual income for loan applicants to Lending Club. A small example predicting loan defaults on page 239, which comes later, for description of the data. Take 3 samples from this data, a sample of 1,000 values, a sample of 1,000 means of 5 values, and a sample of 1,000 means of 20 values. Then plot a histogram of each to produce the figure, and that's what we're going to do here. Okay. Histogram of annual incomes of 1,000 loan applicants, and a mean of 5, mean of 20. Mean of 20? Oh, yeah, the mean. Yeah, I don't know. Somehow I was thinking something different in my head. Histogram of the individual data values is broadly spread out and skewed toward higher values, as is to be expected with income data. The histograms of the means of 5 and 20 are increasingly compact and more bell-shaped. Here's the R. Yeah, there's lower variability in the mean of the sampling distribution, or lower variability in the distribution, sampling distribution of the mean of 20 than there is in the sampling distribution of just 1,000 values. Right, a single sample. Okay. Which one do we want to tackle first? I think I want to just do the iPy notebook one first, and then we'll go from there. So this is in there. I'm going to do markdown thing here. Oh, there is no sub thing here. Okay. We're going to have to use facet grid here. So we'll import pandas as PED and import Seaborn as SNS. And sample data is going to be given by a data frame. We have loans income, so we got to get the loans income as well. So we'll read. Where did the loans income come from again? We have data as the LC loans. Is that what it is? It must be, right? You can always just go back and double check the GitHub here. Just make sure that we have the right file. The notebooks for there, and then I'll go back and I'll look at the R code as well. Loans income CSV. I don't know if I have that one. Don't know if I got that one downloaded yet. Do not have that one downloaded yet. Do I want to do it with curl? Let's do it with curl. Copy the raw. There's an error. I don't know why. Why is there an X on there? There's 50,000 lines. Oh my goodness. Come on, please. I don't want to like go searching for that code again. Guess I will. Not that one. The iPy notebook from the first one. Let's find. Right, go back to. Oh, you son of a. Let's go. Can I interrupt it? Interrupt the kernel. There we go. Okay. I don't want to fuck up the outputs that I already had in there. I hit the play button by accident. Okay, so let's just copy this and then I'll try to see if it works. Should work. Undo. Any changes? No, it's not going to undo that output though. No, didn't undo that output. You can just run that again. It'll be fine. Just to make it cleaner. I don't know why it takes so long. Lord, SciPy stats. Right. So let's curl this. Oopsie. And we're going to call this loans income CSV, and let's just copy that and then go back to the end here. Let's see if that works. Looks good. Yeah, that's it, right? Just that single column, that bunch of numbers. Okay, and then we load that in PD data frame. Yeah. Okay, we're gonna do sample data. So what we need to do is to read that in. Before I do that, actually, let me just make sure that I comment that out. So we don't need to run that again. And import pandas. We need to do loans income, just to be in keeping with what they say, the variables that they use for the data set or the data frame. Okay, here we go. And then we're going to define the column name to be income, and you're going to take a sample from the original data, sample 1,000 points there. 1,000 points of life. And data is the type called I don't know why you need another column for that. And then we're going to calculate the sample mean. Oh, I didn't close the... Okay. Why don't I just copy that and then paste that and then we'll... Sample data, sample mean. 05. Income is going to be a list comprehension of samples, 5 at a time, taking their means and doing that 1,000 times. Okay. Oh, what's that? I should have just copied that one. That would have been the better one to copy. And we're just altering this to be, oops, 20 at a time. If my fat fingers can get this going. There we go. Yeah, and then that's mean 20. And we'll calculate the results as pd.concat, concatenating all of these resulting data frames. Oh, I see why they did the data, and then the mean of the type is a label. That's why we went with that. Let's go with doing the facet grid in another thing, in another cell. And G is equal to SNS dot facet grid. And we're going to do the results. I think we'll maybe talk about that in the next thing. Is the facet grid maybe with the article that I have queued up to read today. Where's the error? Income data, PD data frame, sample data. What's going on? You must pass an index if you're using all scalar values. Scalar values. Is that because of loans income sample? Is that one? Let me check something. I think there's probably an error here. I want to split this. Yeah, and then let me just check out loans income head. Yeah, it's labeled. Let me get info on that then. The column name is X. There's 50,000 entries. Should be good. I don't see a problem. I don't understand. Which line was it coming up with? So the first one, so none of the other ones are able to go. It's probably because of this. What does that return? Let's just see what that returns. Oops. Yeah. It returns a data frame. Oh, I see. I know why. Because it's yeah, this is a bit of an error. I think how do we do this? You don't want to pass a data frame. It's not going to pass a data frame to the income. We want a list. Snapping that, and you're taking the mean. Does that take a data frame? No, I don't think it does. Yeah, I don't think it does. I think what you want. I think what we want is values, don't we? It should be a series, right? It is a data frame, but we want just a series. I think. Let me try this. Let me try. Or you know what? Let's keep that up. And then we'll go under here. Do loans. Income. Just go with X, and we'll take the sample from there. Right. Or let me just test that from there. And that should be a series, right? Yeah, and I can see type from there, and that should be a series. And that should work. If you're passing a series, then that should work. I think there's just an error in this. That's probably why they had the label in there to begin with. I mean, hopefully that works. It looks like it's going. Let me see what I don't know what code or the other thing. Let's take a look at how he did it in this other one. Figure 2.1. Oh, he shows how you got those figures. Interesting. No, it hasn't been updated. This probably won't run. Oh, there's an extra thing. It says squeeze columns. What does that do? Let me see something. What happens if we do it that way? What does this do? Nah, I want to see the function. Really? Come on now. Nothing else? No other... There we go. Series or data frames with a single element are squeezed to a scalar. Data frames with a single column are squeezed to a series. Yeah, that's it. Okay. Yeah, that's some pretty important operation there. I think, yeah, if we do it that way, this should probably return an error because I don't think that's the right syntax, is it? Right? Yeah. There's no whatever you want to call it. Nothing there. No row or column called that. So, okay, so that's interesting. We learned about squeezing the columns of a data frame into being a series. And then that would run then, right? And then that should run. Might take a minute. Surprised we're not setting a I guess it doesn't matter to set a random seed value. So we're going to take the results, pass them into the facet grid, and then label these columns. Okay, so the column, we're going to facet this by the type column, and column wrap means that, yeah, there's one in each row. Yeah, there's gonna be one facet in each row. Then height is 2. Well, I don't know what that's about though. Let me see what does facet grid do? Multi-plot. Can I get more information here? No. Need to take a look at the constructor for that. plt.hist. Oh, okay, but you didn't say to import matplotlib. Really? Because that should come up here. Matplot as plt. That's important. PL comes after PD. Run that again. And $200,000? 200,000. Bins being 40. That's quite a lot of bins. Now, what is the map thing again? Didn't we take a look at that? Apply a plotting function to each facet subset of the data. Okay. So hist function to each one. Oh, this should take a... Wait, function... But that's for every single facet, though. Can you apply different ones? Hopefully we'll get to that. Right, there we go. So it should look similar to theirs. They have these other things. I think R is going to come up with something more like that. Let's have fun with that then. Let's save this. Oh, wait, what happened? MT Rand. Where'd that come from? What? Oh gosh, I think we have a dependency problem here. Pip is terrible. With SciPy and NumPy, they just... gosh. I don't know. Just gonna forget about it. Hopefully, it'll probably come up again if we're using NumPy again. So we need to use the... How did we do this? We needed R for that. Is what we put up into there. And that runs chunk up above and below. I'm going to use the ggplot2 library, and hopefully that is... I think it's installed. It should be installed from the previous sample. Simple random sample. And stamp that data. And we're going to actually have to get read the data in. Now let's try to remember how to do that. Isn't it just read CSV? Yeah, read CSV. Data slash loans income. I think that should work. Probably going to give me an error at some point. What the hell is going on? How come this... What's going on with this? Only use double quotes? Okay. Come on, man. Okay, SAMP data. That data frame, the income is the sample of loans income. 1,000 samples from there. And we're going to label that type as this data distribution, data dist. Take a sample of means of 5 values. Samp mean of 5. And, oh, we're doing something else. Oh no, still doing a data frame, but we're gonna say the income is a t-apply. I forget what the hell this is. Apply a function to each cell of a ragged array. I don't know what a ragged array means. Each group of values or data rows given by a unique combination of the levels of certain factors. One. Okay, where's the funny way to write that, I guess, but I guess in keeping with being able to copy and paste. Replicates the values in X. It is a generic function, and the internal default method is described here. Wow, I don't know what that means. Replicating the data. So that's for a sequence. Sequence there, and then that, and then a fun. We like to have mean fun. Income. Do a label of a mean of 5, and then hopefully we can just like copy and paste this, and then yeah. Mean of 20 values. So just copy paste this. 20, and so where if there's a 5, I bet we have to go. There we go. Let's put the errors here. 2 spaces, but it's 4 spaces. Okay, that's just like your opinion, man. Can I change that in the linter settings? And then, okay, so we'll run that cell as like those things, and then we'll do this as separate. Once we set those up, then we're going to do a plotting of the histograms, or no, we're first going to bind the data frames and forget type to a factor, right? That's what that was. I remember Roger Peng used to have a course on Coursera, and he would talk about that for doing factors. I forget what that was for those. Factors are single categories, aren't they? The type, making them a factor. Different levels. Factor, I guess, just being a categorical variable. Or more like an enum. We have okay, and then we'll do another cell separately with the plotting. ggplots income AES. What is AES again? All aesthetic mapping describe how variables in the data are mapped to visual properties. Right. Aesthetic mapping. So you map a aesthetic to a feature, which is like a variable or something. Plus, we're gonna histogram ins equals 40. As a GERD and type against everything. Is that what that means? really doesn't want me to indent that. Probably because I didn't put the plus on there. There we go. Okay. All right, let's hope this works. Control-Shift-K is gonna knit this document, right? And then I'm gonna have to open it up in another thing. There's an error. What's the error? Cannot take sample larger than the population when replaced is equal to false. Oh, that's interesting. What did I do? Which line? Chunk 2, line 6 through 31. So it wasn't here, but it doesn't tell me exactly where, though. Okay, so backtrace data.frame of I'm missing something. I don't understand which. What is I'm missing? Data sampling distributions. Loans income. Convert data frame to vector. That might be the problem. That might be the problem. Loans income, and then the result from that should be the thing there for a vector. Let's see if that works then. Looks like it did work. Knit that song. Exit code is null. Let's go open this up in so just open it in File Explorer first and then open it in Chrome. There we go. Yeah, okay. So let me put this side by side up over here. Yeah, I guess we could do it like that. That's fine. We got the code here. We can look at the code and then look at the other stuff here. So that looks pretty close to what they have in the book there. Okay. Oh boy. I'm a little bit tired. Oh, we still got to get through. Oh wait, we missed some of the code here. I missed some of the code for the Python. Let me try to rerun that. Maybe that something there. I can where'd it go? Let's get rid of that and get rid of that stuff and go back to here. So we got to do some axis handles. Axis labels, we're going to label it as income on the X and then count on the other side. And then our titles, that's what we're missing. That's weird. Really? That works. Okay. Interesting. You're essentially passing like what will become a format string. Right? Template string, yeah. So you don't need to use format string at all. Just a regular string. Okay. All right, so that looks pretty cool. All right, so then we'll do the central limit theorem and standard error, and then that's it. And then we'll move along to doing data viz in Seaborn right after this here. The central What happened to this? There we go. Okay. There's no more code here. It's just going to be taking notes here. So central limit theorem. So the phenomena we just described is termed the central limit theorem. It says that the means drawn from multiple samples will resemble the familiar bell-shaped normal curve, even if the source population is not normally distributed, provided that the sample size is large enough and the departure of the data from normality is not too great. Wow. I feel like we need all of that, though. So that's one thing there. Departure from normality is not too great. So if it's yeah, heavy skew, right? Well, that's yeah. There's heavy skew, or if there's multi modes. The central limit theorem allows normal approximation formulas, like the t-distribution, to be used in calculating sampling distributions for inference. Right. Okay, I'm going to take a quick break, and we'll finish this up when I get back. Okay, so we're going to define the standard error here. I don't know why they do it. That. We want a fraction. Yep, that looks pretty good. Okay. Standard error is a single metric that sums up the variability in the sampling distribution for a statistic. So let's just want to link to the All right, so that's an estimate then. So that's an estimate of variability, right? Yeah. Could probably link that to the other note. Yeah. So I think we could do standard error. Go. Okay. Interesting. Okay, so as the sample size increases, right, the standard error decreases corresponding to what was observed previously in the figures we constructed there. The relationship between standard error and sample size is sometimes referred to as the square root of n rule. To reduce the standard error by a factor of 2, the sample size must be increased by a factor of 4. Interesting. The validity of the standard error formula arises from the central limit theorem. In fact, you don't need to rely on the central limit theorem. To understand standard error, consider the following approach to measuring standard error. Collect a number of brand new samples from the population. For each new sample, calculate the statistic. Calculate the standard deviation of the statistics computed in step 2. Use this as your estimate of standard error. Okay, I think I want to take a note of that in the, maybe my day here. Don't really need to rely on the central limit theorem. Consider the following for some measure standard error. So let's see, measuring. Just like link to that. Shoot, I should have just saved the other thing. Standard error, right? Here's a shortcut for making an entire thing title case. Oops. Estimates of location, I think. And then it was the mean. Yeah. For example, the mean. Average, okay, yeah. Actually, we should probably look for this. Use that as your estimate of standard error. Interesting. It's pretty much like the process that we used when I was in the taking physics. You do multiple trials. You do a couple trials. Yeah. That's weird. Interesting. So we'll talk about bootstrapping tomorrow. Standard deviation versus standard error. Do not confuse standard deviation, which measures the variability of individual data points, with standard error. So we should probably highlight that one. You know what? Just this part. And key ideas. And I'll just copy those over to my notes from this here. So the key ideas are that the frequency sample statistic tells us that it turn out differently from sample to sample. Okay. Gonna need to sit on some of those things. To let some of those ideas marinate. Variable listed. Okay. That's cool. Cool. Okay. That's what we're going to go with there. This is going to be a pretty hefty article, I think. Might not get through it all. Okay. All right. That'd be cool. Just add that to the here. Does the image get stored? Okay. I'm gonna take a quick break and we'll come back. I'll get started on this article from RealPython. I'm gonna add a stream marker and we'll get going. Okay. Should remember to take stream markers for every section. Be back in a few. All right. Here we go. Let's get back to visualizing data in Python with Seaborn. Okay. Okay, so I got my started up here. Let's go read this here. Are we going to need to download some data? I think let's go take a look at what we need to download. It's the free code. Oh no, we're just going to use the data sets in Seaborn, I guess. Okay. So if you have some experience using Python for data analysis, chances are you've produced some data plots to explain your analysis to other people. Most likely you'll have used a library such as matplotlib to produce these. If you want to take your statistical visualizations to the next level, you should master the Python Seaborn library. I actually link all these things, I think. Oh, interesting. Oh, wow, this is old, but I guess the basics still apply for matplotlib. The object hierarchy. Yep, this is very... yeah, still relevant there. So I do have it listed there. I'm gonna actually... Oops. Copy that as a resource for today, and you know what I'll do? Let me open that up. Let me put it at the bottom of this. Well, the links are there, actually, so I guess it doesn't really matter. The links are in there. Yeah, it doesn't matter. I was going to save the links, but that's okay. You don't need to do that. Statistical data visualization. This is just a sample code, but we'll download that anyway. So in this tutorial, we will learn how to make an informed judgment as to whether or not Seaborn meets our data visualization needs and understands the principles of Seaborn's classic Python functional interface. Understand the principles of Seaborn's more contemporary Python objects interface. Create Python plots using Seaborn's functions and their objects. Okay. Before we start, we should familiarize ourselves with the Jupyter Notebook data analysis tool available in Jupyter Lab, although you can follow along with the Seaborn tutorial using your favorite Python environment. Jupyter Notebook is preferred. You might also like to learn how a pandas data frame stores its data. Knowing the difference between a pandas data frame and a series will also prove useful. It's now time for you to dive right in and learn how to use Seaborn. I'm not using Jupyter Lab, but I am using the Jupyter Notebook. I don't know what you want to call it. The library that interfaces with the VS Code IDE. Getting started with Seaborn recovered. Jump right over this stuff. Open a Jupyter Notebook, pip install Seaborn. Let's do the sample data. That's what we need. From here is from GitHub. Okay, wow. Well, that's Seaborn data, though. Isn't that like doesn't that only to provide a convenient target for the Seaborn load dataset function to download sample data sets from. We don't actually need this. We don't need to download it. It'll download it automatically. All right, we'll just jump right into creating some bar plots with Seaborn. And suppose we want to see a bar plot showing the average amount of tips received by the waiter each day. Could write some Python Seaborn code for this. So matplotlib, we're gonna have to import pyplot as plt, and then import Seaborn as SNS, and load in a tips data set from SNS load data set. This is a function that loads example data sets from the online repository and requires internet. So if you don't have internet, obviously you need to then download it then. And then you just do it as read whatchamacallit, read CSV. So this is going to return a pandas data frame though. So we might need to install pandas as well. So I think we're going to import that. Not install, but ed, and we're going to want to put that up at the top there. Alphabetically ordered there. Or actually, it should go this way, I think. Because matplotlib comes before that. And actually, I think when you do, I forget the spec. I think it's supposed to be like something like that. I think. We do Alt-Shift-F. Oh. Rough seems to think that that's okay. SNS bar plot data equals tips, and we're gonna put in the day as the X categories along the X-axis, and then the tip value along the Y-axis, and we're going to estimate the mean in the error bar. None. Interesting. What's with the estimator there? Okay, so then you can set a title that way. We need to set... Yeah, and then you need to do PLT show. Okay, to show the plot. I think you might need to do that. All right, there we go. So first we import Seaborn into our Python code. By convention, we import this as SNS, and although you can use any alias you like, SNS is a nod to his fictional character the library was named after. I don't even know what this is referring to. Rob Lowe on the television serial drama The West Wing. Samuel Norman Seaborn. Why? What was he? Communications director. Why is it named after him? I'm very confused. This like doesn't. This was a cool bit of trivia, but now I'm like, why was it named after him? FAQ maybe. Samuel Norman Seaborn. Okay, I guess it's just the import. Samuel Norman Seaborn. Network X is NX. I should get back into using it, Network X. It's probably further developed now. More easy to use. I don't understand why it was named after him. Just because of the last name, but like, what's the connection with data visualizations? Like, please let me know what the heck the connection is there. Right, to work with data in Seaborn, we must, or usually load it into a pandas data frame, although other data structures can also be used. It's just a link to, oh, accepted by, that's good to know. Whoops. NumPy libraries. Par. The Seaborn documentation is looking nice these days. All right, so we're going to read a CSV later. Begin with, because you're working with one of the Seaborn sample datasets, Seaborn allows you to online access to these using its load dataset function. See a list of the freely available files on the GitHub repository. To obtain the one you want, all you need is to pass load dataset a string telling it the name of the file containing the dataset you're interested in, and it'll be loaded into a pandas data frame for you to use. The actual bar plot is created using Seaborn's bar plot function. We'll learn more about the different plotting functions later, but for now, we've specified data equals tips as the data frame we wish to use, and also told the function to plot the day and tips columns from it. These contain the day the tip was received and the tip amount, respectively. Okay, but we are doing some like calculation here too, because it's taking the mean of the tips and then it's aggregating them according to day, right? Yeah. So it's grouping by day and then aggregating the mean of all the tips. Like all Seaborn plotting functions can understand pandas data frames instinctively. To specify a column of data for them to use, you use its column name as a string. There's no need to write pandas code to identify each series to be plotted. The estimator mean parameter tells Seaborn to plot the mean y values for each category of x. This means your plot will show the average tip for each day. Can quickly summarize this to instead use common statistical functions such as sum, max, min, and median, but estimator mean is the default. Okay. The plot will also show error bars by default. By setting error bar none, you can suppress them. The bar plot function will produce a plot using the parameters you pass to it, and it'll label each axis using the column name of the data that you want to see. Once bar plot is finished, it returns a matplotlib axes object containing the plot. So to give the plot a title, you need to call the axes objects .set method and pass it the title you want. Okay. Notice that this was all done from within Seaborn directly and not matplotlib. You may be wondering why the bar plot function is encapsulated within a pair of parentheses. This is a coding style often used in Seaborn code because it frequently uses method chaining. Those extra brackets allow you to horizontally align a method call, starting each with its dot notation. Alternatively, you could use the backslash for a line continuation, although this is discouraged. According to Pep 8. Yeah. That used to be the way that they suggested that, well, like some people suggested doing it that way. Pep 8. It's old though. That's the thing. 2013. Line breaks. Gotta be in line breaks. Yeah, okay. Oh, we could refer to this too. Yeah, this should be on separate lines. But it's okay to do this from subprocess import the libraries from, or the modules from a library. Or you can also do that way. And also, yeah, just import those. This is something to read. Read the PEP 8 standards here. Specifications here. Style guide for Python code. Definitely something to read. Okay, in some environments like IPython and PyCharm, which I've never used PyCharm, I've used IPython extensively before. There's also BPython now, a new REPL that's similar to IPython, has tab completion and syntax highlighting. You may need to use matplotlib's show function to display the plot, meaning you must import matplotlib into Python as well. If you're using a Jupyter notebook, then using plt.show isn't necessary, but using it removes unwanted text above your plot. Placing a semicolon at the end of our plot will also do that for you. When you run the code, the resulting plot will look like that. That's what we got there. As we can see, the waiter's daily average tips rise slightly on the weekends. It looks as though people tip more when they're relaxed. One thing you should be aware of is that load data set, unlike read CSV, will automatically convert string columns into the pandas categorical data type for you. You use this where your data contains a limited fixed number of possible values. In this case, the day column of data will be treated as a categorical data type containing the days of the week. You can see this by using tips day to view the column. Right. So might as well just do that, right? Okay, you go. Hmm. Hmm. I don't understand this. And the original data starts with Sunday. The first entry in the category is Thursday. In creating the category, the days have been interpreted for you in the correct order. The read CSV function doesn't do this, but we weren't using the read CSV function. Right, and so to achieve the same thing, you're going to need quite a lot more boilerplate here. You need to read the CSV from tips.csv, right? And so we would need to download it. Okay, well, why don't we do that then? Curl it, set the output for, yeah, just here, but with the... Actually, I think I just do it like that, can't I? Invalid, of course it is, because I didn't put the thing operator. Okay, so nothing there. So, why isn't it working? URL rejected. Why wasn't that the right location? Pretty sure I can just do it like this. I should save it as tips CSV. There we go. Oh, did it save it or did it? I can get rid of this. Oh, we're in the wrong thing. Never mind. Okay, so move that to the right folder there. No, I gotta select the kernel again. That one. Okay, yeah, so we do need to specify the output as CSV. There we go. Then we can read it in. There we go. Average daily tip. So we're going to create a, yeah, a group by object, and we're actually going to create a data frame from this. It's actually going to be a series, is it not? Pretty sure that's a series, right? And take our days. Right. Come on, seriously? I don't want completion there, I just want it to go to the next Hang on. Can we calculate the daily averages? Or we're just creating a list of theories? I mean, sure. um, why are we doing it this way, though? If we're doing it this way, why don't we just do... Why don't we just do this, then? Do, like, a list comprehension. We'll do... and we just put in the day or day in days, and then that should do it. And that should get us a list of series, and then we can make a figure and axis handle, and we can make subplots. Also, I'm pretty sure we could do this without... This could be a good exercise for me to try to tie in what I learned last week and put do the data, what do you call it? The pivot tables. Make a pivot table like this, I think. Could do it that way with a group by. Yep. So that's what you get then, doing it that way. What was the other thing I can do here? We can do tips. Let's try pivot table. Tips.pivot. I'm pretty sure you can plot it from here. What did we take for this? This is a good test. The 4 things we need. We need definitely an index, right? So what are we using for the index? It's going to be I think days. Days. And the or is it day? I think it's day, right? Yeah, it's day. And then we want to know the tip. So the values for the tip. And our ag func, I think, is just going to be the mean. Yeah. And then from there, I think you can just do it as matplotlib. So you can do plt.bar x is equal to I mean, we just make a list out of the days. I think. Let me see if we can figure this out. Back it up, because we don't want to like that. Let's do like this list, day, values, unique values. What do we do when we get values? Let's just try to get that first. Isn't that... Okay. Yeah. There we go. Okay. Coolio Magulio. Yeah, we could do it that way, can't we not? Can't we not do that for our plot? X is going to be equal to that list, and then the height is going to be equal to the it does say list like or scalar, so I don't even think that I need to turn it into a list for that. Wait. What's the name of that? I don't know. Yeah, I don't know what the... Let's copy that, actually. Let's find out what this was again. Right. Hit is the thing we're looking for. There we go, but it's just not in order, right? It's not even correct, though. Right? It's not correct? Yeah, because the order's wrong. So, the day? No. How are we doing this again? Yeah, that's right. Okay, that's it. But we just don't get this the right order. But to fix that, we can set yeah, I don't remember how to do that. You can sort index. Can I do it according to a key? Yeah, I don't remember how you do this. I mean, I could just do it as sort values and do it as ascending, and then that would work. Pretty sure. Oh, oh, but it's different though, because it is less on Friday than it is on Thursday. But that doesn't work. Right, okay, that's weird. What can you use as a key? Because I know you can do it with a lambda. The thing is, yeah, I don't know. Well, like one thing I could do is yeah, I think I need to define it first. Could you do it with a walrus operator? That'd be so funky looking. Be very gnarly. Let's go days dict. You could do it this way and do yeah, I guess we'll just do it individually. So Thursday would be the 5th day of the week or the 4th day? 4th day, right? The 5th day of the week would be Friday, or no, it is. So we're starting on Sunday. Oh wait, no, but we don't want to start on Sunday. We're not Sunday to be for the weekend. This is right. Okay. 7. So we could do it like this, and then you can do a lambda key, and then you can do it like this. The rather than x, do a lookup of the days dict, and then do it as that. And I'm pretty sure we can do it on there, and then you have to do it. Yeah, I think that works. No? Unhashable type is the index because of that. So days dict. Oh, weird. Huh. I have to look at the docs. I think this is outdated. Key is a thing that should work. Sort value should work, but it's not what we want to do. We want to sort the index. It's not what we want. What a crappy thing. Okay. Yes. Should it return an index for the same shape? So it's getting pretty gnarly, but Statistic. What I'm trying to remember what we want this to be called. short days, and then what we want to take in is panda's index. Let's say a PD index, panda's index. So taking a PD index, what is it again? How do you deal with an index of that? Oh, what am I doing? I think I just do that. Does that work? No. Why doesn't that work? Well, let me see something. I already have days dict defined here. What if I try to do a lambda of that works. Why doesn't that work? I don't understand. Yeah, you get that index. And it says that index is not hashable, but it shouldn't need to be. So, excuse me. So an index, I don't understand what the we've got to have some kind of example here. X dot steer out lower. Oh. Oh. Ow. 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 That's not the method that we want. It's close. We got a days dict, and then we can pass in x dot stir. Like that? I don't know. No? X dot stir is the method, but then, wait a minute. That's so weird. That's a string method, though, on there. That's lowercase. So index is equal to that. So I'm very confused at this. That is the index, right? But why is it... Oh, is it because of multi-index? Oh, wait a minute. You know what? No. I'm so confused because the index should work for that. The index is returning something wrong here. Why? I don't understand why it doesn't work. Not hashable. Well, we're not passing the index into there, though. We're passing... I feel like... Yeah. It's an iterable. I don't understand. Why does it not work? We don't want it to be in place. Sort index. According. Yeah, we want it according to that, according to the result of looking up Statistic. Looking up the number in there. Weird. That's so weird. Oh. Level. Oh, maybe that's it. Okay. Maybe we need level is day, I guess. Let's take a look at that. Maybe it's that? No. Still unhashable type. Level equals day. No, that's not it. When we're looking at this, what index is there? Oh, we can just re-index. I think that's what I want to do. All right. Just delete all this other stuff. Just get rid of all that. No need to do all that. Just getting creative here. So we can re-index. And the new order that we want is going to be is that it? Thursday, Friday, Saturday, Sunday. That's what we want. There it is. That's how we recreate it. It's not as bad, right? Just doing the pivot table. So that object, and then one more line. It's not that bad. It doesn't have to be that bad. So all of that is to say, it's not that bad in Matplotlib. If you use pivot table, you don't have to do all this creating a list of series. Did anyone mention that in the comments? How long did I spend on that? That's funny. Let me actually open this article up in another tab, and then I'll want to look at the notes or comments on it. I have comments. I'm gonna put this. I don't want my good work to go unnoticed here. Okay, I want to merge these two. I guess I gotta control shift. Control. What was the thing I was doing? Join cell. Alt Windows J is the next cell. Oh, why did I do it like that? It's so funky. There we go. And then I want to just take this. I'm so, I don't know. Can we add that? Does that work? Where'd the HTTP come from? What? I don't want that. Nobody wants that. Code block. There we go. That's weird. Oh, because we're not doing the subplots. Oh, I guess it is like, or whatever. Doing the labeling is the problem. But like, don't you have to do similar things? Day and tip aren't, okay, whatever. I don't have to be that sassy. PyArrow will become a required dependency of pandas in the future. PyArrow is the Python implementation of Apache Arrow, which is a set of technologies for faster data processing of large volumes of data. Well, if it's becoming a required dependency, why do we have to install it? Should just resolve. Pips should resolve that when you install pandas. Because it's optional now, I think. Begin with, you read the tips.csv file using the pandas read CSV function. You then must manually group the data using the data group data frames group by. You must do it. No, you don't. You can do pivot table. For calculating each day's average using mean. Next, you manually specify the data that you wish to plot and the order you wish to plot it in. When read CSV reads in the data, it doesn't categorize or apply any ordering to it for you. To compensate, you specify what you want to plot as the days and daily averages lists. To produce the plot, you use matplotlib's bar function. Specify the two data series to be plotted. In this case, you pass x equals days and height equals daily averages. Finally, you apply the axis labels and plot title to it. If you run this code, then you'll see the same plot produced as before. Okay, saving plots to a file. There we go. That's the same thing. Still quite a bit of things there. Do we have line numbers on the code? Would be nice. Okay. Yeah, okay. All right, so then in whatchamacallit, you can save it as that. The thing is, if you're going to save it, I think... Oh, maybe they did change it, because it is looking better now in here. Or if you had a dark theme, it would like... It would plot it as transparent. The white background would not be there. It would just be transparent background. And so it would then be kind of difficult to read like a lot of the axes and stuff. All the other things. When you put it on a black background. Open it up in a browser with dark theme or something like that. Okay, so then you can save the figure directly from here by doing figure. Why is this not? Wait. Why'd they change the method of doing set title? Oh, that comes last, but like, can we do it from here? You can set title that way. Or you can just do set and then pass in wargs. But set title is just doing the single thing. You can change the font dictionary and all that other stuff as well. Okay. Either way, so we can do dailytips.png and save it as that, although it's saying that no, I can't. No, I can't. Yes, you will. No, you can't. List object has no attribute figure, probably because you have to edit this part. So that's interesting. It outputs a list. It doesn't return the figure handle. That's the difference. Oops, that title. This outputs text? What? Weird. Weird. Okay, but then why, like... That's not working, I don't think. Oh, it does work. Okay. That ain't working. That's the way you do it. Yeah, it doesn't show up on there. It's a mysterious... That's mysterious. The linter's not picking up on that. So, I don't know. Here you've used the plots figure property. Allows you to access the underlying matplotlib figure, and then you've used the savefig method to save it to a PNG file. The default is PNG, but savefig will also... you can pass in common alternative graphics formats, including JPEG, PDF, and PostScript PS. Is that like an Adobe thing? PS? You may have noticed that the bar plots title was set using the set title daily tips method and not the set. Yeah, exactly. Although you can usually use these interchangeably, using set title daily tips is more readable when you want to save a figure using figure.savefig. More readable? It doesn't even nothing work if you try to do it the other way. Okay, the reason for this is that the set title method returns a matplotlib.text text object whose underlying associated figure object can be accessed using the dot figure property. Okay, but that's not being picked up by my linter here. If you use .set, title is equal to daily tips. Still returns a text object, however, is the first element in a list. To access it, you need to use the... which isn't as readable. Okay, it returns the list. Okay. I don't know what's going on here. Maybe experiencing some buffering. Huh, that's weird. Okay. All right, so hopefully the introduction is giving us a taste for Seaborn. Seeing the relative clarity of Seaborn's Python code over that used by Matplotlib. This is possible because much of Matplotlib's complexity is hidden from you by Seaborn, as you saw in the bar plot function. Seaborn passes the data in as a pandas data frame, and the plotting function understands its structure. So plotting functions are part of Seaborn's classic functional interface, but they're only half the story. A more modern way of using Seaborn is to use something called its objects interface. This provides a declarative syntax, meaning you define what you want using various objects and then let Seaborn combine them into your plot. This results in a more consistent approach to creating plots, which makes the interface easier to learn. It also hides the underlying matplotlib functionality even more than the plotting functions. You'll now move on and learn how to use each of these interfaces. Okay, sounds good to me. Let's move along. Understanding Seaborn classic interface, functional interface. Let's put this image here. Okay, so these are all the plots that you can do. Okay. So a set of plotting functions. It's a set of plotting functions for creating different plot types. We've already seen an example of this. When you use the bar plot function earlier, the functional interface classifies its plotting functions into several broad types. The three most common are illustrated in the diagram below. Okay. That's weird. Okay. This might be a good thing to take a note of for me. Oh, this is all the same. I think I do want to take some flashcards. Let's open up the flashcards that I have for... where did I do this? Oh, Polar's flashcards was in the job notes. What we want is Seaborn flashcards. Let's open up that Polar's one. And what we'll do is we'll just like copy this. Make a copy of this. And we'll just call this... Seaborn flashcards. There we go. And from here, what we'll do... No, I don't have that. Okay. So libraries are going to be underneath that there. And so what we want to do is to extend this as... Wait, what? Data viz? Okay. Oh, maybe I did put it under there. I don't think that makes sense. Data visualization matplotlib, that doesn't make sense. I think data visualization coupled with programming language Python matplotlib makes sense. So I think I want to wrangle that tag, and I think I'm just going to wrangle that now. Let me go ahead and actually let's bring that up. Matplotlib there, because I think what I can do is we can wrangle this tag. Yes, we can rename it. And what we're going to do is we're going to rename it as programming language Python matplotlib. And there we go. Only five. So that's the way I wanted to do that. Data visualization coupled with programming language Python matplotlib is the intersection of those two things. And I can just get rid of that now. Okay. Now, let's see. What we want is to do like something like along the lines of a multi-line comment or flashcard, I think. Quiz myself on the objects of Seaborn. Yeah. Oops. I don't know how this is doing this. I might need to expand this. Just do like something like object description, something like that. What it does. Yeah, so something along those lines, and I think what we can do. Yeah, I think that works actually. Wow. So how do I? Oh, that's right, because that's the center of the thing. It's not like all wide. Okay. Excuse me. How do I want to note this? Seven. What are the 7 stat objects in Seaborn? We're gonna like put that there. It's that. And so what we'll do is put a Does that work? What? That sucks. Baby, you okay? 1 second. Okay, what do we want to do here? Okay. Well, what is the thing I want to do here? Spaced repetition. Notes? Wait, which the templates? Oh, it's only double. Never mind. Okay, so maybe it's that. There we go. What are the 7 stat objects in Seaborn? Ag, Est, Count, Hist, KDE, Perk, Percentile, and Polyfit. Doesn't show. So the problem here is that it's not rendering the tables. Does it render tables? Let's see. And then show the answer, and then this is the 7 stat objects. Right. Yes. So it does, like, it ends up working there. Okay. So, yeah, I'm going to add these to my list of things to review. Yeah. So it's a bit of a pain, though. So we'll do move objects. Yeah. We have the object and what it does here. You son of a birch. Son of a barch. There we go. What are the 4 scale objects in Seaborn? Give myself some flashcards and make me learn how to do these things. So we can become an expert in scale objects in Seaborn here. So, filter. Also want to look at the functional things here. Look at functional ones. For it's actually 3 relational plots. I think what I can do is just copy all this. I kind of I'm feeling like I do want to become an expert at this stuff. At Seaborn. So, relational plots. And so what I'll do is, we should probably just do something like this. Object and what it does. And we'll just copy that. And we'll just go like that. And then we'll delete that from up there. And then what we'll do there is so I think I'm gonna just go and do these first. So if I do this, okay, I think I can do that. And then just do that, and then just hit enter on all of them. Yeah, and I think that should work on all of them, honestly. Yeah, okay. And then what I can do... So, if I want to cram all the notes in here, let's do go and see if we can select the deck to cram. We do have Seaborn. So what are these? These are the like plot objects, I think. The stat objects. Don't know that. Stat objects. Rel plot, scatter plot, line plot. Those are relation plots, right? I think they're relational plots. Scatter plot and line plot, I think. Relational plots. Nice. 7 stat objects in Seaborn, right? There was ag, est. I don't know the others, honestly. It's going to be a while. I don't know if these are really good flashcards, but I'm just trying to get back into the habit. What are the 5 move objects in Seaborn? I don't even know. Don't know that one. HDECDF, the empirical cumulative distribution function. Dist plot is deprecated and plot marginal. Okay, so we should probably edit that and just get rid of the deprecated ones. Marginal distributions by drawing ticks along the x and y axes. 6 distribution plots. Relational plots, right? There was there's a linear regression one, the scatter plot, regression, scatter, and line, I think, right? Or rel plot, relation plot onto a. Okay. Regression, I'm not sure. LM plot, reg plot, and resid plot. Yeah, so this is interesting. To do the flashcards there. So I'm going to actually add in flashcards here. Seaborn flashcards is what we refer to there. Also have that one, right? Oh, that's not it. That one, RealPython. Yeah. Here we go. All right, let's get back to the tutorial here. So function classifications. You've got rel plots, scatter plot, and line plot. You have distribution plots, which are hist plot, KDE plot, these ones. Strip plot, categorical plot. So, okay. First column shows the relational plots. These help you understand how pairs of variables in a data set relate to each other. Common examples of these are scatter plots and line plots. For example, you might want to know how profits vary as a product's price rises. There's also a regression plots category that adds regression lines, as we'll see later. So the second column shows Seaborn's distribution plots. These help you understand how variables in a data set are distributed, and common examples of these include histogram plots and rug plots. What's a rug plot? I don't know. For example, you might want to see a count of each grade obtained in a national examination. The third column shows Seaborn's categorical plots. These also help you understand how pairs of variables in a dataset relate to each other. However, one of the variables usually contains discrete categories. Common examples of these include bar plots and box plots. The waiter's average tips categorized by day, which you saw earlier, is an example of a categorical plot. And you may also have noticed that there's a hierarchical structure to the plotting functions. You can also define each classification as either a figure level or axis level function. This allows great flexibility. A figure level function allows you to draw multiple subplots with each showing a different category of data. For example, you might want to know how profits vary with the price increases of multiple products, but want separate subplots for each product. The parameters you specify in the figure level function apply to each subplot, which gives them a consistent look and feel. And so the rel plot, dist plot, and cat plot functions are all figure level. Okay, well that's pretty good. Let's go ahead, go back to here. So what we want is to single out these other things. Let's see. The plots, the relation plots. So rel plot, I'm going to take this, cut that out, cut it out, place it right there. We'll get another one from this plot, to be confused with that plot. And we'll have to like say, what are the two relational plots. That's less things to have to remember then. And then the 8 categorical plots. So cat plot. That's where you plot all the cats. All the cats get plotted on that cat plot. Cat plot. Oopsie. Oopsie. We do that and then, oh no, we don't want to do it like that. What we want is the object and what it does, right? So we want to do or we're gonna remove the distribution plot is no longer there. Is be there. So there's only 4. 1, 2, 3, 4. That's less information to remember. We'll just get rid of the ones that are deprecated. Don't have to remember them because they're not going to be used in future versions, but maybe, they might be useful, but I'll make sure that we understand ones are which. Okay. Okay. So Seaborn also contains the disk plot, but this has now been deprecated, replaced by hist plot and disk plot. So in contrast, an axes level function allows you to draw a single plot. This time, any parameters you provide to an axes level function apply only to the single plot produced by that function. Each axes level plot is represented with an oval on the diagram. And the line plot, his plot, and blocks plot functions are all axes level functions. Okay. The term axes is one that's confusingly named. You might think it refers collectively to the x and y axes of a plot, but this is certainly correct in everyday language. In Seaborn, an axes object is the correct term for a plot. This is where axes level functions get their name from, and next we'll take a closer look at how to use axes level functions to produce single plots. So did we? Yes, we did. Okay. Fun with Seaborn. So let's go with, I don't even remember what level that was at. Let me just go back up here. Okay, so let's just using axes level functions. And then we'll use figure level functions. So that's going to be good. Then we'll do introducing Seaborn's contemporary objects. Interface, nice. That's nice. Deciding which interface to use. And then we'll go creating different using functions. I don't know why I keep using the code thing. We don't need to use it. Code. Whatever you want to call it. Creating categorical plots. We'll do categorical plots using functions. We'll create distribution plots. And we'll create relational plots. Okay, so we have moving stat objects that we did kind of take a look at in the beginning. Or at least, in our flashcards. Alrighty, okay. Doopity. Ooh. Ba ba da ba 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 da ba. Axis level function. Python. Let's get some Python going on. When all you need is a single plot, you'll most likely use an axis level function. In this example, you'll use a file named Cycle Crossings APR June CSV. This contains bicycle crossing data for different New York bridges. The original data comes from NYC Open Data, which is it sounds like a data source. It sounds like a data source that we were looking for. New York Times. That sucks. New York City Open Data. Get data from. We can get data from there. Let's go there. Open data for all New Yorkers. I mean, I'm not a New Yorker, but like, can I get the data? Can I have the data from there? Did I make a note of like that? I looked at data sources here today. Seaborn flashcards that we have up on there. Never mind. We took note of that. Okay, so we're gonna get the cycle crossings. Oh, it's in the downloadable materials? Okay, so a copy is available there. I wonder... It's archived. Attachments there. It's in XLS format as well. What are actions that we can do? Share and embed. We can get download. .zip. Is it doubly zipped? Why would it be .zipped? What? What? Zip it up and zip it. Inside the zip folder is another zip. I guess not. Maybe it's not. Okay. Well, that's Microsoft Excel. It's not CSV. So, we're going to say no to that. And you know what? Let me go back to that. Back to downloads, and let's go materials, Seaborn visualization. We'll just extract all to our projects. Oh, there. Analysis projects, Seaborn. Select that folder. Maybe it'll like. Yeah, I guess it's fine. It doesn't matter. Should have just kept the original one. It's fine like that. That's okay. Let's see. We should have propagated the populated the. Oh, it's in assets. What do you mean assets? Why do I have an assets folder there? Daily tips, CSV. Why do I have an assets folder there? There's nothing in there, right? There's no assets folder in the other things that I've done for there. Maybe it was touched by it was touched by what do you want to call it? Obsidian. Touched by Obsidian. Nice to be touched by Obsidian. Okay, so we will read that in, and I'll just get that out of the way there. We do have pandas already loaded. We don't need to go, making redundant imports here. Cycle crossings. There we go. And then we'll just import that. Right? Now let's make a plot here. Kai, suppose you want to see if there was any relationship between the highest and lowest temperatures for the last 3 months of data contained in the file. One way you could do this would be to use a scatter plot, and Seaborn provides a scatter plot axis level function for those very level partially purpose. It sure do. Okay, so sns.scatter plot. I'm going to pass in the crossings data frame to our data part, and the column we want is the min temp for the x-axis, and then we're going to plot that against the max temp and try to see if there's any relationship here, right? Then what we want to do is to set certain aspects of the plot. We want to set the title, minimum versus maximum temperature, and I'm just going to copy that word because I'm going to misspell it. Minimum temperature. Y label maximum temperature. And then we can do like PLT show. It's not really necessary here, I don't think. This should return an axis. An axis? And there we go. Look at that. With just that one little line, we get this beautiful little plot. Alrighty then. That's the way we do it. Now, to use the scatter plot function here in a way that's similar to how you use bar plot, and you supply the data frame as its data parameter, then the columns of the plot. As an enhancement, you also call matplotlib's axes.set method to give your plot a title. And use X label and Y label to label each axis. By default, there's no title, and each axis is labeled according to its data series. Using axes.set allows capitalization. Although each figure level function requires its own set of parameters, and you should read the Seaborn documentation to find out what's available, there's one powerful parameter that appears in most functions called hue. This parameter allows you to add different colors to different categories of data on a plot. To use it, you pass in the name of the column that you wish to add coloring to, apply coloring to, right? The hue. Huey doing Louie. So let's do the same thing. We're just going to copy this. And we're going to create a new thing right underneath it. And we're going to add a line to here, to the calling of the scatterplot function. And pass in the parameters for hue And the size is going to be, so it's going to be both colored according to the month. So this is like akin to the R aesthetic mapping, I think, the AES thing. So you're doing the hue is going to map the month to the color or the category. That's kind of like the facet or the factor factoring, I think. Size is going to be month, and or it's like the group by, right? It's like grouping by month, and then the size is going to be given by the month as well. Why would we do the size of the as the month, and the style of the month, and the, I don't know. That's a little weird to me. Then we'll do the legend title as month and see what this gives us. Okay. So June is the smallest dot on there. I don't know why you did it as size. Just to like illustrate that there's like how it handles different things. So it's perfectly possible to set hue, size, and style to different columns within a data frame. By setting them all to month, you give each month's data point a different color, size, and symbol respectively. You can see this on the updated plot below. So it looks pretty nice. Pretty nice indeed. Although applying all three parameters is probably overkill in this case, you can see how which month each dot belongs to. We did all of this within a single function call as well, and notice also that Seaborn has helpfully applied a legend for you. However, the legend's default title is the same as the data series passed to hue. To capitalize it, you use the legend function. You'll see more axes level plot functions later in this tutorial, but now it's time for you to see a figure level function in action. Okay. Figure level function, gonna do those figures, gonna get them figures. Okay, well, I mean, we already loaded that. So let's see, sometimes you want to several subplots of your data, each showing the different categories of the data. You could create several plots manually, but but a figure level function will do this automatically for you. As with axes level functions, each figure level function contains some common parameters that you should learn how to use. The row or column parameters allow you to specify the row or column data series that will be displayed in each subplot. Setting the column parameter will place each of your subplots in their own columns, while setting the row parameter will give you a separate row for each of them. Okay, so I need to see a visualization of this. I'm not quite understanding row and column here in this sense. I guess because it's like a facet grid like type of thing. Is that what we're going with? So let's get the rel plot going. And we'll put in crossings as our data frame. The column, again, is going to be min temp, and the Y is going to be the max temp. Those columns, and the kind is going to be a scatter plot. Okay. And the month is going to be... What's going on I gotta fix my keyboard here. Like something stuck under the space bar. Column is equal to the month. I'm gonna set title. Oh, God, I don't want to do this again. It's like, give me all this nonsense again. Oops. There we go. That works. And we can set the title as the legend actually right inside there. I don't know why that happened. we can do plt.show. Okay, pretty cool. Can we zoom in on this? Maybe not that much, but that is going to be the result there. You can save it too from there. Okay, so as with axes level functions, when using figure level plot functions, you pass in the data frame and highlight the series within it that we're interested in seeing. And in this example, we use RealPlot, and by setting kind is equal to scatter, we tell the function to create multiple scatter subplots. Ooh. I don't know why you plot the min temperature against the max temperature, to be honest with you. I mean, you can clearly see a relationship here. As the min temperature increases, the max temperature increases. I mean, that's... yeah, as Peoria goes, so does the country. Okay, the hue parameter still exists and still allows you to apply different colors to your subplots. Indeed, you're advised to always use it with figure level plotting functions to force Seaborn to create a legend for you. But it's not the hue parameter, though. It's kind, right? So it tells you the kind of thing. But the hue... What do you use the hue thing for, though? We didn't use hue. Oh, we did for the month. Right, okay. Right, even though call does it, though. Oh, each will be in its own column. What if I did it instead as row? So if I just take all of this stuff, copy it, flip it and reverse it. Okay. There we go. Now the x-axes kind of line up. We could do it that way as well. Gets a... what? Why does it like give the title for every single one? I think that's a little odd. Could you pass in like a list here? Let me see something. Oh, it's just string. X labels just string as well. So the figure level plot functions, such as RealPlot, create a facet grid object upon which each of their subplots is placed. To capitalize legends created by figure level plots, you use the facet grid's legend accessor to access set title. You may then add the legend title for the underlying facet grid, and the plot now looks like that. Yeah. Created 3 separate scatter plots, one for each month's data. Each plot has been given a separate color, and a handy legend has been prepared to allow us to identify what each plot is showing us, and we'll see more examples of the function's interface later, but for now it's time to meet the relatively new kid on the block. It's the Seaborn's objects interface. Ooh. I think this is a good time for a break. So, yeah, I'm going to take a quick one and come back in a few minutes and dive into this. We still got a lot to go through, but we're going to do it. We're going to get through this. So, be back in a few. You hungry? I'm about to be rabbit right now, huh? Yeah, you want a little bit of food? No? Want a little bit of food? Yeah. Is that what you're after? No. Okay. Seaborn object says so. Build a plot using Seaborn objects. The first object that you use is plot. This object references the data frame whose data you're plotting, as well as the specific columns within it whose data you're interested in seeing. Suppose you wanted to build up the previous temperature scatter plot example using the objects interface. A plot object would be your starting point. Okay. So, sure. Import Seaborn objects as so, and then build it up, right? So you build it up. What? So plot object crossings x equals min temp, y is equal to max temp dot show. Okay, well, that's the first part of it, but there's no data. You want more food? You're really hungry, aren't you, big girl? You might want your dinner early, huh? Yeah. Hey. Daddy. You're really hungry. Want food? Yeah, it's okay. I think maybe we're missing something here. Let's see, what does it say? An interface for declaratively specifying statistical graphics. I want to try to explore this. Hang on a second. And again, I just like every single thing that I kind of come across, I like to even note like where I was. So ggplot, let's say, versus Seaborn objects. Introduce Seaborn's object system. This is going to be closer to ggplot. It is based on the grammar of graphics, so that's interesting. So there is Hadley Wickham did like release like a paper on like the grammar of graphics, right? If we look at there we go, a layered grammar of graphics, outlining the a tool that enables us to concisely describe components of a graph, right? Graphical poems. Right. They have the preprint. This is from 2010. Don't I have this in here? Let's Google. Okay. This is probably something I should read too. G-plot, Q-plot, GG-plot, Q-plot. Ooh. That's honestly pretty effing cool. Recreating that. That's pretty effing cool. Okay. I have to excuse me 1 second. Okay. Layered grammar. That's exactly. I want to put this into my notes here. It's definitely something I want to read at some point. The grammar of graphics. I wonder if there's a newer thing here. What? What? I'm not a robot. You need a $200 book for this? So this, okay, so this comes back to... Okay, so Hadley Wickham was applying the grammar of graphics to create a library for R called ggplot, is my understanding then. Okay. So I guess Tableau uses a similar syntax and stuff like that. This new system, or similar framework, however you want to describe that. This new system represents a new way to build visualizations in Python. It's powerful, flexible, and easy to use, and it's because data visualization is so important. I'd argue that this is an important development for the Python data ecosystem. New to me. I did not really know that you could do like that. I know that Plotly was trying to do something similar, I feel, with their framework as well. With like Plotly dash and then like Plotly objects or something like that. So I think that was what it was. No, what was it doing? I want to save this Seaborn data GitHub repository to my in here. Objects, plots. Okay, so there's methods you can use on it. This is really pretty neat documentation, except for the fact that there's really not a lot of examples. Very, not a lot of examples, but like it's as long as they explain it well, should be nice to work through. So do I have the... Yeah, we do. We have Python axes. I'm just gonna like copy this and just put it into here. We don't need to do this, I just want to. So what's... I'm not sure. Okay, so it does just give you the blank thing there. When you use the Seaborn objects interface, it's the convention to import it into Python with an alias of SO. The above code reuses the crossings data frame that you created earlier. And so if you're like watching this, you can see that the way I learn is very weird. At least in terms like maybe it's not weird. Maybe you do similar things that I do. Fundamentally, my mind just wants to explore. So when I come across something that is interesting to me, I let it fly. I let it go. I let myself go find out, something that I want to find out. And I find that works for me. Like, I don't... Like, it enables me to make the connections quicker than just having somebody, like, read out all of this stuff to me and then have me have to, like, swallow it down and have all those questions that are popping up in my head suppressed. And, I just want to explore those questions in the moment. It's just the way I work much better that way, and I'm much happier then. To create your plot object, you call its constructor and pass in the data frame containing your data and the names of the columns containing the data series that you wish to plot. So here, these are min temp for X and max temp for Y, and the plot object now has data to work with. The plot object contains its own show method to display it, as with plt.show discussed earlier. You don't need this in a Jupyter notebook, but when you run this code, the output may not exactly excite you. As you can see, the data plot is nowhere to be seen. This is because a plot object is only a background for your plot. To see some content, you need to build it up by adding one or more mark objects to your plot object, and the mark object is the base class of a whole range of subclasses, which each representing each representing a different part of your data visualization. One point to note is that a plot object could be reused for a range of different plots. For example, if you assign your plot object to a variable such as temperatures, you can later reuse the same object and create different plot types by adding different content onto it. Remember, the plot object only contains data for visualizing. Interesting. So you can do like... that's pretty cool. Next, you add some content to your plot object to make it more meaningful. So we're going to add something onto here. And so I'm going to do this in sequence in here, layering on these things rather than just like adding on to the same cell. I'm going to add on to I'm going to copy and paste into a new cell and then add on from there. And then so I can add on so.dot, and now I can do a label of title. I don't want, is that still there? No, it's not. I don't want to I don't know why I just don't want to use those things again. I just don't want to type this again. Basically the same thing. The only thing we need to do is to look for label and then do that. Just do... Okay, that works. And now we have our stuff. Okay. Okay. Oh. Okay. Hi, Paisha. You okay? Paisha's being very clingy right now. When you run the code, it looks like the same as your first scatter plot, even down to the title and axis labels. I might need to take her out. in a moment. This would be a pretty good stopping point to come up onto deciding which interface to use, and then yeah, so that would probably be a good stopping point for the moment. And we can come back. I'll take a like a longer break. Yeah, I think she needs to go outside. So what I'll do is we can paste that, or we can paste this entire thing. Select all. Paste that down below, and then what we'll do is we'll add on to this. So we have min and max temperature, and then we also want to add the color for the month. Oops. Let's hang on one moment. We'll capitalize? Okay. Oh, cool. Separate each month's data into markers with separate colors. You pass the column whose data you wish to separate into the plot object as its color parameter. In this case, color equals month will assign different colors to each different month. This provides similar functionality to the hue parameter used by the functions interface you saw earlier. To apply different marker styles to the dot representing each month, you need to pass the marker variable to the same layer that the dot object is defined on. In this case, you set marker equals month to define the series whose marker style you wish to differentiate. So you label the title and axes in the same way. Wait a minute, did I do that? Oh, I didn't add those. I didn't add those. Wait a minute. What do we have to do? Marker equals month. We need to do that. So we're adding dots. And what are the dots again? The dot objects. Yeah, those are dot objects. Okay. Okay. Oh, it's very nice, it is. Okay, and then that's that, and then one more plot, and then we'll take a break. Okay. Now label the title and axes in the same way you did earlier. Label the legend. Use the plot objects.label method. Passing it color is equal to string capitalized. You'll apply the strings capitalized method to the default label of month, causing it to display as month. The X and Y parameters could have been set in the same way, but the underscores would have remained. You could also have set color equals month for the same result. The plot now looks like this. Yep. And we have a similar looking plot there. Next stage is to separate each month's data into individual plots. Okay, so we can do this. We can do it. We can do this. Excuse me. Ooh. You add facets. Add facets. Oh, God, what's going on with my voice? You can add facets. Oh, funky. Okay. And then you change the layout and you can change the size of the... Okay, cool. So each one is getting a like 5x5 grid here. 5x5 square for each graph. And you facet it by column. Okay. Create a set of subplots, one for each month. You use the plot object's facet method by passing in a string containing a reference to the data that you wish to split. In this case, column equals month. You separate each month into its own column. And you've also used the plot.layout method to resize the output to a width of 15 inches by 15 inches. This makes the plot readable. The final version of your object-oriented version of the plot now looks like this. As you can see, each subplot still retains its own color and marker style. The objects interface allows you to create multiple subplots by making a minor adjustment to your existing code, but without making it more complicated. With objects, there's no need to start from the beginning with a completely different function. I was expecting this to be a review, and I am learning new stuff from here because this Seaborn library has been like further maturely developed now into with this yeah, it's amazing like how much they've done in just a couple of years. So great job with the to the devs on working on this library. This is pretty nice. We're gonna take a break and we'll be back to go through deciding which interface to use, creating different Seaborn plots using functions, and we're going to create Seaborn data plots using objects. So we're just going to branch out from what we did before, and we're just going to make it a little more complex, I bet. So stay tuned. I'll be back in an hour. If you're watching this live, I might set up a clock for myself to keep myself honest. I don't know how I want to do that, honestly. I'm not going to do that, but I'll put in the ticker. Yeah, I'll put in the ticker something that says the time that I'll be returning. Yeah. So it's almost 5 my time. So if I give myself like an hour and a half, I'll just say I'll come back at 6, and so 6 p.m. Local time, which I'll translate to East Coast. I think it's 2-hour difference. So I'll come back at 8 Eastern, 5 Pacific. Yeah. All right. Be back shortly in an hour.
Medicine, or one of the ways, one of the various techniques that we can use to attack cancer once it starts. The idea being, rather than going in and just zapping the cells with radiation or chemicals or whatever, that we can use immunotherapy. In other words, we learn how to control the body's own existing immune system, like the cancer tumors. And if this can work, it works in some cases, doesn't work in others yet. This is what we're studying. We'll talk about in the episode. But it's not just a more kind of organic, natural way to fight disease, but then the person who has had therapy has that extra layer of protection.
Just finishing up playing a little free poker on PokerStars with play chips here. We're gonna sit out the next big blind. I like poker. It's a fun game. Playing Omaha. Pot limit. Ooh, Matt Bomber wants to put in a lot of chips here. Do I want to play this hand? Oh gosh, no. Oh man. I could probably go with this hand and probably be in decent shape. But these guys are just nuts. Oh my gosh. Queens ends up winning it at the end there. Okay, not bad. P there. I need to figure out. Oh, that's it. That game busted. Okay. Leaving the table. All right, so we're a little bit low. So let's finish up this day with some stuff going on. We're gonna try to. Why does it do that? I hit shuffle, but it doesn't actually shuffle. Weird. Okay. Yeah. Deciding which interface to use. Seaborn Objects interface is designed to provide you with a more intuitive and extensible way of visualizing your data. It achieves this through modularity. And let's see. Let me actually put this back in the chat. I don't know if I never did this. Didn't put this link in the chat there. Seaborn Objects interface is designed to provide you with a more intuitive and extensible way of visualizing data. It achieves this through modularity, regardless of what you want to visualize. All plots start with the same plot object before being customized with additional mark objects such as dots. Using objects also gives you plotting code, your plotting code, a little more uniform look. So, wait. Oh. Leland Wilkinson's book and Hadley Will. Well, yeah. Ooh, sorry there. Aesthetics, geometrics, objects. Right. Aesthetics are mappings, and then the geoms are the geometric objects. Okay. Yeah. Yes. Okay, we want to. Yeah. Oh, wait, but with Plot9? What the heck is Plot9? Oh, it's so old. 5 years old. That's ancient. ggplot in Python? You can use Python. Oh. Oh. Well, that's interesting. That's so funny. I didn't know that they had a ggplot. If you're coming from R, then you can use Plot9. Based on ggplot2 from the R program language. Huh, that's so funny. I didn't even know that. Grammar of graphics for Python. Plot9. Let's add that here. Okay, so the objects interface also allows you to create more complex plots without needing to use more complicated code to do so. The ability to add objects whenever you please means you can build up some very impressive plots incrementally. So the interface is inspired by the grammar of graphics. You'll therefore foresee that it resembles plotting libraries like Vega, Altair, Plot9. I've heard of Altair, but I didn't. Vega Altair. I thought there's something else though. Vega Altair. And then Declarative Visualization Library. What is Altair though in Python? So it's the same thing. Okay. I've heard people reference this. Interesting. Alrighty. Okay. The Objects API is also still being developed, and the developers make no secret of this. Although the Seaborn developers intend for the Objects API to be its future, it's still worthwhile to keep an eye on what's new in each version, pages of the documentation to see how both interfaces are being improved. Still, understanding the Objects API now will serve you well in the future. That's probably true. So, I can't believe that Seaborn is still... They made so many improvements to this, and they made the documentation much more complete, which is nice. I still can't believe it's in version 0.13. It's not even like in a version 1. I don't understand this versioning. I actually want to look at something. What's up with Seaborn versioning? I have no idea, like, what's going on. Polars and Seaborn. That's interesting. Oh, wait, the newest version of Seaborn accepts Polar's data frames natively. Note that this is not full native support, though. Okay, so what I was saying before, though, oh, it's not full native support, so I don't understand what the... full native support, I don't understand what that... So there's got to be third-party stuff, right? Is what that means? All right. Hang on a second. Let's try to get this done in an hour. Let's see. So you shouldn't abandon the Seaborn plotting functions entirely. They're still very popular and in widespread use. If you're happy with what they produce for you, then there's no overwhelming reason to change. In addition, the Seaborn developers do still maintain them and improve them as they see fit. They're by no means obsolete. Also, remember that while you may personally favor one interface over the other, you may need to use each for different plots to meet your requirements. So in the remainder of the tutorial, you'll create a range of different plots using both functions and objects. Once again, this won't be exhaustive coverage of everything that you can do with Seaborn, but it'll show you more useful techniques that will help you. Once again, do keep an eye on the documentation for more details of what can be done with the library. Okay, so we are up to... okay, that was it. Just reading for that. So what's new in each version? We should probably make a note of that. Change log, right? Change log there. What's new? What the heck? Okay. So now let's create some different Seaborn plots using functions. So we're gonna learn how to draw a range of common plot types using Seaborn's functions. And this is kind of new to me, I think. Or no, the object thing is definitely new to me. More familiar with the functions. So let's see. As you work through the examples, keep in mind that they're designed to illustrate the principles of working with Seaborn. These are the real learning points that you should grasp to allow you to expand your knowledge in the future. To begin with, you'll take a look at some examples of categorical plots. So the categorical plots are a family of plots that show the relationship between a collection of numerical values and one or more different categories. This allows you to see how the value varies across the different categories. So suppose you want to investigate the daily crossings of all 4 bridges detailed in cycle crossings there, although all the data you need to do is to do this is present. It's not quite in the correct format for analyzing by bridge. So, I mean, we already have the crossings thing, right? So it just wants us to... Okay, yeah. Right. Finds bar. Right. Melt. Yes, that was another method that I was thinking, wanted to remember how to use, right? Problem is that to categorize the data, it's like to go from long to wide, from long format to wide format, right? Currently there's a separate column for each bridge. To sort this, you need to use the dataframe.melt method. This will change the data from its current wide format to the required long format. You can do this using the following code. Okay. Right. So what I was thinking, what is... Yeah. Right, because the columns, we need Brooklyn, Manhattan, Queens, Williamsburg, and Queensboro as a single column. And then the value has to be something. Is that the number of crossings or something on the bridge? So we're going to turn the bridge type into number of crossings. Yeah, so it's going to be two columns. So one's going to be categorical with Brooklyn, Manhattan, Williamsburg, and Queensboro as the factors, and number of crossings is going to be another thing, right? So I'm just doing that by examining. So I'm thinking, yes, so the bridge and then the crossings. All right, so testing my understanding. Okay. Bridge crossings, melt. ID vars is equal to day and date. Those are both IDs, the day and the date. So we're going to have a multi-index here. Or is it multi-index, or is it just that you have... Yes, I think that's true, right? I mean, the date and the day are synonymous. Well, not really. The day is kind of redundant. It's a redundant column. You don't need the date and the day and the month. Unless we want to use that. Oops, let me do like this. Williamsburg. This is real data, right, from New York City. So we're going to map the day to just capitalize day, and then the date to capitalize date. Right, there we go. And now we have a longer format. And the day, I guess we might use the day as something and then use the date for something else. To reorganize... Oh, look at that. It goes Saturday, Sunday, Monday, Tuesday, Wednesday, Brooklyn. Okay, that's interesting. To reorganize the data frame so that each bridge's data will appear in the same column, must first of all pass ID equals vars, or ID vars equals day date. Okay, so each bridge's data will appear in the same column. ID vars, each bridge's date, data. I don't think you need the list. I think you could do this with just the one. I want to just test that idea. I don't think you need it like that, but I could be wrong. Let's see, because let me see what the melt function. Wait, what? Really? ID vars is a tuple, but why are we passing it as a list? Or it could be a sequence as well. Or it could be scalar, okay? I mean, it could be just scalar. We could just do this as the date. Like, I'm pretty sure that would work too. No? Why doesn't that work? ID vars or value vars are not present in the data frame. Keynes borrow. Well, that's what happened. What happened there? What? There we go. Yeah, that works, right? We just get the date, and that the day is just a little extra, I guess. So I'm just gonna like do that with that, and we'll rerun this again. Okay. I don't know why we need to have, not necessary. They're used to identify the data being reformatted. In this case, each day and date value will be used to identify the data for each bridge in this and future plots. Maybe it comes in later. I don't know why. You also pass in a list of the values whose day and date data you wish to appear in one column. Yeah, the value vars. Okay. We have to take the factor. Yeah, the factoring of that. Or the value vars being the columns, the names of the columns. Right. A list of bridges, since you want to list each of the bridge crossing values with their day and date. So make your plot labels more meaningful and capitalize for neatness. You pass in the var name and val name parameters with the values bridge and crossings respectively. This will create 2 new columns, and the bridge column will contain all of the bridge names, while the crossing columns will contain the crossings of each for each day and date. Finally, you use the dataframe.rename method to update the day and date column names to day and date respectively. This will save you from having to change the various plot labels the way you did before. As you can see from the output, the new bridge crossings data frame has the data in a format that you can more easily work with. Note that although only some Brooklyn Bridge data is shown, the other bridges are listed below it in the full data frame. Okay. So let's do a bar plots for bridge crossings, and we're going to do the day as the X, and for categories, and then for our numerical, it is going to be the crossings, and the bridge is going to be the hue or the color. No error bars. And we're going to use a sum as the estimator. Right. And then we're going to plot this here. PLT.show. Cool. Nifty looking. Look at that. Brooklyn. Not as many crossings as Williamsburg, which has the most, right? Cool. Code is similar to the earlier example of a bar plot where you analyze the tips data. This time you use the hue parameter for each bridge's data differently, and also plot the total number of crossings by day by setting estimator is equal to the sum. This is the name of the function that you wish to use to calculate the total crossings, and the resulting plot is illustrated below. As you can see, the bar plot contains 7 groups of 4 bars. Okay. 1 for each bridge for each day of the week, and from the plot you see that the Williamsburg Bridge appears to be the busiest overall. I need some more water, jeez. We want to investigate further, so we want to look at the we want to create a box plot of the Wednesday crossing. So we want to make so we're going to locate, so using the label locator, we're going to locate all the crossings for the days in Wednesday. So that's why we're doing this. Okay, so for all the Wednesdays. You could also just take from the date. I think the date might actually be like a date time or something. maybe not though. Rename columns. And we're gonna change the month to capitalized month. Just make it neater, I guess. Do bar plot here, and we'll do the data is the Wednesday crossings using the day column for the categories. Williamsburg. And the hue is going to be the month. We're going to by month. So, but this is just Wednesday, I thought. Oh, this isn't a bar plot, it's a box plot. Oops. I'm going to set the X label to none. And just put the redundant plt.show, even though we don't need it. There we go. So, okay, so Wednesday, but then we're, the hue for month. So each month on a Wednesday. So more in June than in April. What's going on in June? And then there's an outlier for a day in May. Haha. That's funny though. What is that? Is that a marathon? Although not a marathon, but what is it? This is bicycle crossings, right? How do they count that? This is bicycle crossings, I'm pretty sure. I guess they're using some kind of video capture counter or something. Must be something going on in May that has like some kind of race or something that's crossing the bridge. Use the axes level box plot function to produce the plot. As you can see, its parameters are similar to those you've already seen. The X and Y parameters tell the function what data to use, which setting hue is equal to month provides separate box plots for each month. You also set X label equal to none on the plot. This removes the default day label, but leaves Wednesday. Okay. Right. So the tick is labeled Wednesday, but the axis is not labeled day. Okay. For each of the 3 months, the height of each box shows the interquartile range, right? While the central line through each box shows the median values. Horizontal whisker lines outside each box show the upper and lower quartiles, while the circles show outliers. What does it mean, the upper and lower quartiles? Second and third, and then the first and fourth for the outer ones. Okay, right. I don't know why I blanked on that. Using the principles that you've learned so far in the Seaborn documentation, you might like to try the following exercises. Oh, this is actually one that we didn't get to do, right? With the previous one. So let's, yeah. Oh. So let's, I can just like, what? I don't know what just happened there. Did it get moved up? So weird. There it is, okay. Heck, man. I don't know. I haven't. I'm getting pretty tired, man. Okay, drawing categorical plot. And what we're going to do is we're going to copy this. I'm going to paste that right to there. Create multiple bar plots for the weekend data early. And with each day on a separate plot but in the same row, each subplot should show the highest number of crossings for each bridge. What do you mean? Multiple bar plots for the weekend data only with each day on a separate bar plot. A separate plot, but in the same row. What do you mean by that? Multiple bar plots for the weekend data only? Do you mean box plot? Bar plots for the weekend data only. Oh, that being Friday, Saturday, and Sunday, or just Saturday and Sunday? Each day on a separate plot, but in the same row. Okay, let's see if we can do this. So we want to do sns.barplot. I haven't even been paying attention. The data we want. So we want to actually create our weekend data, right? We did this with the locator, and we did crossings. Right, where the day is in. So this is weird. Right, okay. And then we renamed the columns. From month to month. I guess that's just... Okay, and then what will we do? I might have to just use the example. So the data is going to be the weekend crossings. And each day is on a separate plot, but in the same row. Right, well, I mean, the hue, we know for sure the hue has to be the day. No, the day should be on a different plot, so I'm not sure I understand. Was the hue month? Or, yeah, the hue is month in that one, but the hue is day for our thing there. And then we can do like... Yeah, I'll do that afterwards. So the hue is day. The X... What we want for the X is each bridge, right? Yeah, I think. Separate plot but in the same row. The Y value that we're gonna go with is crossings. Interesting. Okay, is this what this is though? me see if that is what we want. Bridge. Is the day. We want the day to be. Can't interpret x is equal to bridge. What? I guess estimator. Can't do bridge for x. Wait a minute. So, wait a minute. What? Wait a minute. Oh, that's right. Never mind. Day is in there. It's the capital. Oh, and then we just do the. Is this what we were going for? Saturday and Sunday for each bridge? Is that what we're going for? What is that? Okay. Multiple bar plots for the weekend data only. Each day on a separate plot, but in the same row. I don't know what they're going for here, honestly. Let me see what they're going for the first one. Task 1. So we're good there. But okay, so we have to use a different thing then. We have to use sns.catplot. Yeah, I don't know what they were going for here. This is like, it's not something. This is really a extra. It's an extra thing, right? Like I think I got the idea right. We just need the column in there for the day and then the error bar. Estimator is the max. Oh, I got that wrong. The kind is going to be a bar for each one. We're going to set the X label to none. There we go. So it's facet grid. But why? No, this doesn't even look right, though. Why Saturday and Sunday? That don't look right. Unless we did something wrong here. Bridge Brooklyn, Manhattan, Queensboro. Yeah, so why are these not... Why is the Sunday on there? I might actually have to look at the example that they have. See the tutorial. Okay, so we should run all, selecting our kernel there. Okay, task 1 is what we're looking for here. There's definitely something like incorrect going on here. Day. Yeah, so we did that, and then we did... I actually don't need the month in there. Maybe that's what it was. What happens if I get rid of this? I have the exact same code. I don't understand. Var name is bridges. I put bridge instead. Yeah. Wait a minute. Where to go? Var name is bridge. I maintain that it should not be plural. It should be bridge because it can only ever take on one value. It's only going to be a singular bridge in any entry. Yeah. The variable is referring to an entry. It's not referring to the list of things. All right, so they get the same thing. It just seems odd to me. So then, like, what is with task 2? Let's actually go ahead and copy this. See if you can draw 3 box plots in a row containing separate monthly crossings for the Brooklyn Bridge for Wednesdays only. So we already have the Wednesdays only data. So we're gonna I think we have to use the category plot, right? Cat plot, or it's gonna be this plot. This plot, I'm pretty sure. Yes, I'm pretty sure that's it. Because the kind that we can use here, I think, hist box? Wait. Really? Not rel plot. Cat plot is gonna be... Okay, I think it's wrong. I think it's wrong. I think it should be this plot. Because if you want to be plotting the distribution, showing info about the distribution, which is going to be a box and whisker plot. Or box plot, right? So we know we're looking for a box plot. Our data is going to be Wednesday crossings. Our X is going to be, so what do they want? They want monthly crossings for the Brooklyn Bridge only. So I think we want month there, and we want the Y to be Brooklyn. Right. Okay, I think that's what we're going for. Then the hue. Wait. Bridge crossings. So we only want Brooklyn Bridge. And we want for each month. So we want, yeah, I'm pretty sure we want the X to be the month. Although, wait a minute. Wait a minute. We're looking at this one. Q is the month that separates into 3 different things. The Wednesday. And we want to do it over, you know, 3 different box plots. Separate monthly crossings. So each month. We don't want the hue. We want the call to be month. Or the, what do we do? Yeah, we want column. We want the column to be the month. We want the Y to be Brooklyn crossings. Day. Why is X equal to day? What does that even mean on this? You want the X to be the day. I'm confused. I'm so confused. Why do we want the X to be the day? Like, what is that mapping to on here on a box plot? I need to look at the... long form data. Yeah, but what is the X? First, second, and third. Oh, wait a minute. Oh, right, because this is Wednesday, Wednesday, Wednesday. I gotcha. Wednesday, Wednesday, Wednesday. But we want Wednesdays over... And yeah, and so from here, we'll do set... Wait, what did we do? X label. Is this what we want? No, kind must be box plot was passed. KDE ECDF. Oh, okay. That's almost what we wanted, right? Actually, save this one. Shrink it a little bit. month is April, May, and June, and this is all for Brooklyn. Right. So, is that what we want? Is that what they wanted us to do? Wednesday data. I guess that's it. I guess that's what they wanted. Month, Brooklyn, days, X, and I guess that's it. I guess that's what they wanted. That's what they wanted. Okay. Then success, I guess. All right. Okay, creating a bar plot with matplotlib. Wait a minute. What is that? What happened here? Creating a bar plot with matplotlib. That was oh, that's what happened. Wait a minute. Where was that supposed to go? That was supposed to go all the way up here to there. Well, that's not good. So if I select this one, Alt up. All right, I think okay, creating categorical plots. Now we want to do dish plots. Those were all categorical. Okay. Yeah, this was an exercise. Yeah, that's it. And then creating functions. Distribution plots using functions. Okay. This might take a while. Alrighty. Distribution plots are a family of plots that allow you to view the distribution of data across a range of samples. This can reveal trends in the data or other insights, such as allowing you to see whether or not your data conforms to a common statistical distribution, one of the whatever. I think I'm going to actually end it before finishing creating Seaborn data plots using objects, because it's getting a little late. Oh, God, what's that? And we can pick it back up tomorrow. Yeah, because we will review job boards tomorrow. Do that. And we'll do linear regression on Thursday. Weekly review, and then we have monthly review to do as well. Friday. Lots going on then. Working on projects. Maybe I'll work on projects on Thursday instead. I think that's what I'll do, because I gotta pick Molly up from the airport at some time. At that point, I don't remember what time exactly though. Check. time I'm supposed to pick her up. Okay, I do have that at that, right? Oh. Okay, wait a minute. I gotta duplicate this for a second. Yeah. Just gotta do some maintenance here. There too. I should. All right, I think that's gonna be good enough. So I just need to delete this one. Right, okay. Okay. All right. Pretty sure that should show up as busy. There we go. Yeah. I need to do my monthly review in the morning. That's probably what I should do. Our projects on Thursday morning. And we'll do linear regression in the afternoon. Okay. All right. Back at this. Okay, so histplot allows you to create histograms, which are useful for visualizing the distribution of data by grouping it into different ranges or bins. So we have the serials.csv file, which is provided for us. First thing that we'll need to do is read the serials data into a data frame, obviously. Serial data is equal to the pd.read csv of the serials data csv, and then we rename some columns of rating to rating, and then we'll just take a look at first 5 rows here. Okay, we can also do describe. You can do info, get an idea of what's going on here with this. Load 64, int 64, and then objects. So we have some categorical things with the name and the manufacturer, and then we have ints and floats as our other stuff there. Okay, cool. I'm getting tired. Okay. So suppose you want to find out how the serial ratings vary between cereals, different cereals. So create a histogram showing the distribution of the rating count for each cereal. Okay. How many bins? 10. 10 bins. Then from there we want to set title equal to serial distribution. Okay. And that gives us this. So all the axes level functions you've used, you assign the data parameter of histplot to the data frame that you want to use. The X parameter contains the values that you want to count. In this example, you decide to group the data into 10 equal size bins. This will create the 10 columns in there. Okay, so cool. As you can see, the most skewed towards the lower end, and the most popular rating of the cereals is in the high 30s. Common distribution plot type is the kernel density estimation. We talked about that with the practical stats. This allows you to analyze continuous data and estimate the probability that any value will occur within it. To create the KDE curve for your breakfast cereal analysis, you could use the following code. So let's try to use that. Right, there's the KDE curve. KDE curve based on probability of appearing the various parameters past the KDE plot function have been the same meaning as those in his plot that you used earlier. And that's the result. And so this curve provides further evidence that the distribution of serial ratings is skewed towards the lower end. If you pick any breakfast cereal, serving the data set at random, it'll most likely contain a rating of around 40. A rug plot is another type of plot used to visualize data distribution density. It contains a set of vertical lines like the twists in a twist pile rug, but whose spacing varies with the distribution density of the data they represent. The more common data is represented by closely packed lines. Less common data is represented by... I gotta see this. I don't understand what is going on here. So... they'll explain the height thing, I'm pretty sure. Question I have. I don't know what the height is gonna mean there. Distributino. Oh no. Oh, okay, the height of the bars. It's like a barcode. Oh, I guess we want to plot the SNS KDE plot on top. There it is. Interesting. Okay, so we'll do the examples. And so then we'll do the figure handle ones using the exercises. That's what we're doing. Okay, I understand now. That's... Wait, which one? Yeah, it has to be number. Drawing distributional plots. Okay. And then so we'll do that, and then up above that, we'll just do these ones, and then I'll just split them up. Oops. Shoot. We want to produce a single histogram showing serial ratings distribution such that there's a separate bar for each manufacturer. Keep them same 10 bins. So the hue we want to be the manufacturer, right? So what we want to do, there's going to be this plot is what it's going to be. Do we have to do any massaging of the data at least? I don't know. We probably don't because that's not really a part of this. We have the manufacturer. We have the name. Okay. So we want to split it up by manufacturer. Right, so the X value is the numerical value. We want the rating, but I guess we want the hue to be... manufacturer, and the kind to be hist. Is that what we're going for? Is that what we're going for? I think maybe, but it's all on the same histogram. Oh, but we also want the bin size. Be 10 as well. Oh, that broke it for some reason. Is it bins? Bins. Okay, there we go. Separate bar for each manufacturer. Yeah, it's messy though. It's messy as hell. Nabisco is higher rated though. In its own land, right? Okay. I think that's maybe what we were going for. And then let's see if we can do this one. See if you can superimpose a KDE plot onto your original rating histogram using only one function. Okay, wait a minute. Because we have the axes thing though. Oh, I think I know. But you want to superimpose it on top? So we're going to do the same thing. Except rather than that, we just do KDE, right? No, that's a different thing. Probably because of bins, right? There's no bins. Yeah, I'm betting that that's the reason why. But this is a figure thing, though. It's not superimposing it. Can you do an axis so it takes the current axis? No. Well, that's not right. Can you do height? No. I don't know. Is it supposed to be normalized, though? I don't... Like, I think that's what they were going for. I just don't understand... There's other stuff we have to do for this. Okay. So update your task to task 1 for each one. I'm thinking maybe it's not this, though. I'm thinking what we do is a different thing. Or his plot. Or instead of that, we do it like that. Still doesn't look right. That's... I don't know if the rating goes down to negative. Oh, because of the KDE? Oh, probably because of the KDE. It's 10 bins. 10 bins is correct. Just a matter of doing the other thing. So update that so each data manufacturer calorie data appears on a separate plot. So we're gonna update task 1 so that each one shows on a separate. Yeah. Calorie data shows on a separate plot along with its own KDE curve. Turn an error. Okay, we do have that. It's just not giving me the KDE plot for each of them. Maybe it is because, but it's just not. I don't understand. Let's go back up to here. Let's look at their solution here. So it's just his plot. Okay. I don't know where the multiple is coming from. Where did that come from? Like, that's just out of the blue here. Okay, so the multiples are dodge. Can you, like, overlay or something? What are the other options? Fill, layer, stack. Layer, maybe? Fill. Look at that. Okay, that's interesting. You can stack them, which maybe isn't a terrible way to go about it. That's not a bad idea. Dodge looks a little funky. I guess I really fucked this up, though. Alright, that was mine. That's their solution. Okay. I don't know what I'm doing. So then their idea for the second part is just use his plot. Not use... Oh, you have to get on with the overlaid one. I didn't know that was a thing. My God. I guess we're supposed to read the docs. I'm just like, it's just too late for me to bother. Or not this plot, but this plot. The data is serials data. I definitely need more practice with Seaborn. Oh, wait a minute. You know what? It's okay, I think. Well, I think what I can do is do... There we go. Oh, we didn't do the KDE. Now you can get the kernel density estimation over top of it. Okay. This is a helpful plot. Now this is interesting, right? That's a very handy one. I think ideally what I would like to do is spend some time mastering like each type of plot in the future. I might just end it here. I mean, relational and regressional plots. I want to make sure that I'm understanding stuff, so it's gonna think in a lot better tomorrow. I'm just really tired. It's been a long day. We covered a lot. So yeah. Oh, it's been a lot. So what we'll do is we'll just say that we left off at relational plots using functions. Left off there. So I'll pick back up there tomorrow. I'll just leave this up. We'll do that tomorrow morning. And start from there. And then after we finish this, then we'll go on to exploring jobs. You know, look for job opportunities and stuff. Also, I would like to, and also continue with practical stats. So the main thing is to get through the job stuff. So let me actually make sure that I solidify that plan tomorrow before I close out here today. Oh, wait a minute. That's not where I want to be. Over here is where I want to be. Let me just set my plan for tomorrow. I'm going to spend a couple hours working on job boards. So I think what I'll do is we'll do that through lunch. And wait, actually... We'll do that after lunch. Or actually, like, during lunch and stuff. I'll try to start early tomorrow. Give myself 2 hours to do this. Which is skills-based stuff. And this is... I could just copy this for the description. I really need to find a replacement for calendar for Google Calendar, replacement for Google Calendar. The good thing about Google Calendar is that it's kind of segmented. It's kind of separate from the other things I use Google for. So I might be able to get away with doing that. Maybe we'll have an early lunch, and then what we'll do is we'll finish up with the reading. Of course, this will go late. It's pretty late, but I hope to get a good start tomorrow. And this is going to be... Where did we leave off again? Where did we leave off with the book? I guess I can open it up in my second chapter here. Just look at the outline. The bootstrap, right. Bootstrap confidence interval, normal distribution. Bootstrap confidence intervals, normal distribution. Let's go back here. Yes, FDS. Yeah. And description, we'll just put Can we do a list? How do we do a list? There we go. Bootstrap. Confidence intervals. And the normal distribution. And that's also skills as well, kind of. Yeah. Bullseye. Give me 2 hours to do that, and we should finish that. Finish data viz, Seaborn, explore job boards, and then that will be the little tree at the end. That should be a day. Yeah, I kind of want to review one job role on one of the job sites, so I'm going to kind of flesh those things out as well. 3 hours that I take for that. All right, little by little, we'll get there. Let's move the needle. So, I guess I could take a look at my note for today. Viewed calendar, we already did that yesterday. Did these things. I didn't really take a look at my to-doist tasks. That's going to come into play a lot when I get into job search, because those are the things I really need to like little tasks that should only take a couple of minutes, or like some little things that should only take 20 minutes, rather than doing the time blocking that I've been doing with whatchamacallit. Completed tasks, doesn't show any there. Notes, no. Quick notes, notes that we used or created today. Well, that's weird. Oh, why is it listed twice? Oh, it's a readme for the things we downloaded. Okay, never mind. Seaborn flashcards. Create some of those. Gonna have to like schedule doing that. Sampling distribution of a statistic. We did selection bias, sample biases. All that. Took America's whatever with the FDR thing, right? Which they had Alf Landon winning over FDR, and it was a total bust, of course. Alf Landon was never president, as far as my understanding. As far as I remember. Visualize data with Seaborn. So, yeah. That's it. And then so last year we did some stuff there. This week's projects, we worked on those things. Took some notes on the... Oh, interesting. We got notes from there. I should flesh those out. And I wanted to turn these into flashcards as well in some way. I thought I was trying to do that. I guess I just never got around to that. For these things. Time allocation. Oh yeah, that was kind of just a way to look at those things. Sibilate is to shush your friends. Is to sibilate at them. Utter with a hissing sound. Funny. Okay, so we planned. Forgive myself for not finishing this. That's good. Did I show appreciation for anyone today? I don't know if it did, but you know what? Thanks, Josh, again for letting me use the music here for the background, and I'll be sure to say thank you in text as well. So, yeah, appreciate you all. Gonna close that for today. I'll see you.